heard the name. But think after a while I got to hang up my games. Because at first, my first grade, I knew the work, but I just didn't do it like how we wanted it. And I was so upset because I didn't get a good grade. But the final morning, I got a 91. So my second paper was like the successful seal. I still was that. And I was like, I can't afford to be in this class. Child, I study and I study and I study.
And look at you now.
You have to class on Thursday? What are you talking about? I ain't trying to get it. I said I got an email from him saying about the 46 code.
Yeah, we have test Tuesday.
Or the zip codes.
Yeah, on Swift codes, we have,
You didn't get back any papers or anything?
our exams wasn't finished yet.
Oh, okay.
Test Tuesday,
On the other
Thursday
way,
is the quiz on chapter.
the others.
Whatever chapter is last week I would.
So we had to give us the questions on Tuesdays. From Tuesday to Thursday.
Yeah, he gave us the quiz. Well, he didn't guarantee when he was gonna give us the quiz, because he said he had to make sure everyone took it or something.
What, the midterm?
Yeah, the midterm. Now, you mean like how you tell us what to study? No, he didn't give us that chapter. I guess he's gonna give us that Tuesday.
Okay. Alright, it's getting so interesting. My supervisor's out of office and my supervisor's out of office. Plus, I was feeling like it's coming out through my sinus is bothering me. So I was like, you know what, I'm just tired. I don't know. I don't know. You just know everything. You just you want to talk to me? You want to talk to me?
You're right.
Which class this is again?
Stats. So what you taking this semester, the summer?
Just regular.
Start of going to one view.
It's awesome. Like every single moment Like
I
the
think I got
class.
in after it. I didn't like them, you know, because I felt like it was all about investigation, and I worked in compliance before. Like it was good. Like the scenarios were good, but the beginning for me, I was so upset when I got that little grade. I was like, oh my god, I think And now even in stats, like I kind of like worried multinational again. I'm doing awesome now, like whatever.
I thought that would have been more harder for y'all, but
Mm-mm.
y'all sound like y'all enjoying him.
Jonathan, he's telling you what to study. He's giving you questions. Remember what he's doing. He's question number 1. He's talk fast, so you wouldn't catch the questions. But if you record it, you could go back and type up the questions and find answers in the book. The man giving you multiple choice.
Sure.
So for me, that class is a breeze. But this class, it is just that I'm not a maths person, but I have to get in that math mode. I need to get a new calculator because my calculator giving me some wrong figures.
I think we'll be getting ready to do
You won't have
something.
no calculator, eh?
I'm making sure to do that. Before every single time it comes around to exams, we need to buy a whole set of calculators to rent to y'all. Because y'all is coming us the last minute for calculators.
Yeah, because see with my own, I know how to use the factorial.
Pardon?
You're supposed to have them there for.
Gee, I don't know.
Oh, no, we're gonna rent them to y'all. We're not gonna.
You think they need to rent it? Our last class, they need to rent?
Yeah.
My calculator's free goes, man.
Our last bit of money we can make right off of y'all. If you ain't even go buy it when you know you needed it through the whole class and then come last minute, yeah, we can rent it out. Why not?
I missed that. That's my calculator. Who might have wanted to put up buy with a cheap $5 calculator for my people.
Yeah, and then if we had them like scientific ones ready and available, we could rent them out to y'all for like what?
I supposed to
One good
stuff down the hill. I need to
$10.
go get me a new calculator, Charlie. This one is awesome.
Now the thing is, what I'm trying to figure out,
Don't mind me.
is there someone else that usually be online with you
Mr.
also?
Roll, is there any way to go on like a site? Can you recommend any sites?
Okay, is the other classes be the other gentleman?
A little.
I
I mean, it's for me. It is difficult, you know. I think I'm having problems with my calculator. So first and foremost, it's just been cutting off of me, so I need to get more.
Alright.
But I didn't have time. But I mean, I don't know. I feel like
I gotta go a little closer.
I don't know.
You using the projector today?
Because you teach
First and
well,
foremost-
and I understand.
First and
But
foremost, I think.
Oh, Gia, by the way, we're recording
that's
also,
stuff on
okay?
YouTube, clearly.
yeah.
Stuff on
You're
YouTube,
welcome.
Some instructional videos on YouTube. And then,
Jesus, don't slow
I
down.
mean, I have a couple of students who sometimes if they wanted to do extra practice here, they would come to my classes at COB during the week.
I'll say that again.
Time to
It's every night, 6 days. Yeah. I mean,
Oh, yeah, I was
sometimes
trying to get a little closer
with
moving
the
the
practice, and then
projector.
the other thing is to practice.
Yeah, that's what I tried to do. Last week when I went home, I started to read some of the questions and just.
That's
better than the way
on
the board, so
effective.
I know what maths, you can't study maths, you have to practice maths.
That's, yeah. Because I mean, I can clearly
Alright.
see this exam that
I was like,
Make sure.
what? And then what you, I know what you do too. It'll be the same question, but you word it different. And then I say, hold on, what is he trying to say? Like, what is he asking? And I don't know. But I can pass this class. I just feel a little down.
Hi.
I don't have your exam yet. Nobody gave it to me yet.
I feel a little down, Dennis.
Gia, you done emailed yours to who exactly?
You want to take the side of me anymore? No, because I'm black.
Oh, okay. I got to call him to see if he actually gave it.
Yeah, that's all.
What child?
I have neither.
Oh, I'm gonna get them for you. I'm gonna get them.
Mr.
So don't think for inviting. Alright. Be right back.
Rody, taking points from this homework. Are you gonna record that?
Which homework I gave you back?
Hey, do I get some more homework? Well, you do good. You get 15.
Say well.
I just was talking to
I was
Mr. Rody.
expecting a grade like that.
I tell him I need to go online to stuff.
Oh, this rounding again for me.
It wasn't bad though. It was just one or two things here or there.
I think I overthink a lot of this. exam, I know that for sure.
Oh my god, Mr. Roll, I convinced you just love bracket. Let's see this. No,
Would
no,
you
like
read it?
no.
Oh,
Like no, what do you do? No, okay? Oh my god. Mr. Roll, I need some extra glasses.
Me too.
So you can come to this class at 2
What time?
6 to 9. Monday through Thursday. I need some extra glasses.
It's the same class?
But are they at the same level now, like that?
You don't bring your food in.
No time. I wanted to go buy a new calculator this morning. No time.
What this is,
I
right?
say Mew.
What is mu?
I don't know. What is that?
Mean.
Oh, it's
Okay.
okay.
Oh.
Now what okay mean?
Yeah.
Yeah. Excuses. I rushed this N5 when I came here. After I realized when she showed me what I did wrong. I didn't mean to be so
One,
sloppy.
I did one. And then I
Like,
know it was
usually
wrong.
I'm not sloppy.
Mr. Roll, how come I could not get this balance? I got 0.03.
it's fine.
You sure you're not gonna have a heart broken?
Yeah, child, my heart is broken.
I don't need to see.
That's
They
fine. I
get
mean,
it.
sometimes
Yeah,
that'll happen because of rounding. If you don't round to.
So would that
Let me
be
check
wrong?
it for you and tell you. Just read
Because I know
it.
you say your answer should
I
be
know, I'm telling you.
more than one.
Yeah, but it'll happen sometimes if you round. I mean, depending on rounding. I mean, sometimes if you don't round to 6 decimal places, you might end up with 1 to it, something like that. But it's
57
okay.
ain't that? This is my
Jesus
second
Christ.
time.
What you got, 60?
57.
That's so good.
This is my second time and it's
You can pass. You got to put together. We're going to pass.
I'll
Okay.
cry.
Mr.
Can we
Roll,
cry? Any points for crying?
Mr. Roll, can we get some more homework today?
You can always get more
Yeah,
homework.
please, if that would help.
Hold on.
You don't even need me to give you homework. You can always do homework.
Okay, or this means what?
If I gave you, or took in your exam and gave it back to you, you just got the point for the homework. I don't really go through homework and say, oh, it's this one thing. Yeah, I just look at what you did and if it's right and if it's I mean, even though the answer itself might not be 100%
Right.
correct,
At least
so I can see the
we know.
concept is right.
Okay.
Yeah, it's the quizzes and the exams where I'm really trying to pinpoint.
But
errors.
honestly
Oh,
though,
God.
I don't do work this sloppy,
So,
okay?
Mr. Roll, what's the formula for Q3?
The formula for what?
Question 3? Like what was supposed to be there? Doing there?
Right here, what do you want?
I'm so tired.
What is it you're asking me? Yahim, right?
Yes. Question 6 a recent study observed that 33% of the motor vehicle drivers on the island of New Providence know how to properly select lanes.
Uh-huh.
And then it was saying calculate the means and the standard deviation of the distribution. Can we go over that?
We're gonna go over everything
Oh, good.
because these things, everything we've done in class, everything. Yes.
Like I said it before, and it's hard to understand the language sometimes.
Hi.
We just need to find out who are the highest and sit down together.
How are you? You gave me, I gave you your homework back
Yes,
last.
sir, but
Yeah.
you said to.
You brought in the other one?
Yes. You gave everything back to me. And you said to do everything.
Good. More
And
than
I did.
that.
You gave me
Do
extra
the
work
highest
that I
mark.
did.
Let's
Who won the highest mark?
You.
I don't know.
I didn't get the highest mark.
Let me see.
Okay, let's get started. We have quite a bit to do today.
I didn't get it.
No, we are not. It's still about
What's the grade?
What is it? What did you say, Mr. Dinger?
So,
What did you say?
You want me to read that?
Yes, and it's your handwriting.
You want me to read that or you want me to whisper it?
Yeah, you can whisper it. That should not be here.
Are you telling Mr. Rowe he have a bad handwriting?
I do.
Yeah, oh, yeah,
This
put
game,
it that
right?
big, that big question mark.
Uh-huh.
I said, Mr. Rowe, you like writing? So what is it? Like, he says, no.
I said,
He's
come
like,
on, Elkin.
What was
Man, you know what did he come with that?
Just laugh before. Why are you feeling like this?
No, he know it like that. You know? Okay, I know. Okay, you should not be.
I come on, sound like I used serious.
So this way.
The last time.
Okay, kind. Okay, it's okay.
We just gotta go over different churches.
I agree. For it was a divide and conquer, Mr. Rowan. My mind was really fixated on trying to get to work, and after I started thinking about getting to work, that's when it started to come to me. So
Yes, I'm saying.
I have it. Okay, so let's get started. Let's try to get through this and as quickly.
So we going over the exam, Mr. Rowe?
Yeah, so try to do it as quickly as possible
Okay.
because we have our lecture to do today.
You don't mind saying till 6 tonight?
No, that's not possible. Okay, so question 1, part A. You guys ask how many elements are there in the above data set? So how many elements are there? Meaning how many individuals or people were associated with this study? 400.
Oh, 400.
I put 400. I put
I am
400.
so upset.
Well, didn't you get it right?
Yes, sorry.
I was thinking it couldn't be this simple.
I was like 400 don't sound right.
No.
Part B.
Well, it is.
How many variables are there in this data set?
Two.
2.
Oh,
The major
So,
and whether or not it was graduate school.
so I could get a point for that?
You did.
I see a big zero.
No, you didn't.
for B.
Down the line. I believe you.
So Mr. Rowan.
Quickly. We have to quickly get through that.
Yes, this
Yeah,
question's
no,
out.
I mean I wanted to ask you about the finals. When are we having the finals?
Listen,
No,
let's
let's
quickly
go
try
on
to get
with
through this.
Go ahead.
See? How many observations are there in the data set?
400.
Less than 400.
400, yes, I got that.
Oh my god, I won't be like so bad.
Which variables are qualitative and which are quantitative?
Qualitative is what, 3?
How many variables are there?
Yeah, sure, right?
Right, so-
Rather on the right.
No, 2 variables.
There are only 2 variables.
Right.
Undergraduate major and
Right.
whether or not the person went to grad school.
Right.
Right? There are 2 variables. So since there are only 2 variables, then you can't have more than 2 qualitative and or quantitative variables.
Oh.
So some people said, oh, that there are 4 qualitative variables
So
and 2
it's just
quantitative. Right. So
I give you-
which variables are qualitative and which are quantitative?
I did 2 qualitative means like yes they graduate or no they're not
No.
graduate.
The variable is just graduate school. Did they go to graduate school? That's one variable. The other variable is what is the undergraduate major?
Well,
Right.
I was
So,
just looking
see,
at business, engineering, and others. I
See,
don't know why.
a variable just means what? This is a category that is allowed to vary.
Okay, okay.
Right, it could change from person to person, from person to person. You might have gone to graduate school, I might not have. You might have studied in business, you might have studied in engineering, right? So, the first variable is, did you go to graduate school or not? The second variable is, what was your major?
Oh,
So then, since there was only graduate school, yes or no, an undergraduate major, business, engineering, or others, then both of those
would have been
have to
qualitative.
be qualitative.
Yeah, so it's 2 and 2.
Yes.
I was thinking the quantitative would have been how many did in each category.
I just was like business and
Like that's
engineering,
counted.
and then the others. I don't know what that about.
And then part E said what measurement scale is used for each variable? They're both nominal.
Nominal. Oh,
Okay? So that's that.
That hurts. 1, 2, 3, 4,
I mean, all the points
5.
gone.
That's 10 points lost
Yeah.
easily.
Okay, so question 2. I was surprised a couple people didn't even do question 2.
I know that's two other things.
But
I
did you not do it?
I didn't, but yeah, I don't know.
Question 2 is my weakness.
Probably.
No, I like those actually. I don't know why I like those, but I don't know what happened.
What you get? Why does it feel as if I'm sitting so far back?
You sit here.
Okay.
Man, ain't that rocket side. Yeah, go up there. Yeah, there's him. Come on, play with you.
I'm sitting next to him, bro.
You see the camera there? You can move the camera.
Why don't you move the camera?
Shaking the table.
I see what I did.
Maybe something to shake up their light.
Yeah, go, come up here, William.
It's just right now, it's just guys.
Yeah. Yeah, so I have a few.
Wanna do?
I have 0.73, I don't know where I got that from.
Okay, I have A and B career. C and D is what I have to find out. C and D.
Morning, Mr. Road.
What? Joy, right?
That's me.
Yes. Bullet? Oh, this is you. I was writing these notes too. Oh.
Oh no.
No, I don't know why I thought it was her.
Somebody else.
So you can ignore this one.
Oh, jeez.
I thought this was a lady. So who sits there?
That's when, what, 85?
How you know the highest is an 85?
I don't know, I just guessed. I can't get a point for guessing.
Oh my god.
Sure.
What do you get? What long your day?
Okay. So, question 2. There you go.
Yes, Mr. Roll, I do agree with you.
You know, you say you're dropping those two, or is this the actual that we got?
Let's try to get through this. Like, try to get through this. We can deal with all of those housekeeping things later on. And I didn't say that. I gave a very specific algorithm on the grade distribution and what we would do.
I just want to know if I was this smart. That's what I
Oh my god.
You're like, God, I'll give it. You don't have any right now.
Can I have your
I don't know
phone?
why you
It's
asking,
just good.
why you asking that kind of question? You want me to read? You said I should take it back and have a look at it
No,
again?
that's good. You don't special grade amongst us.
No, because that gave us hope. So
Yes.
you could
Come
do
on.
it.
You guys are done with this?
Yes, sir.
Hold on.
Delicious.
Let me just put the last one.
Okay. So, question
Oh,
3
geez, I
then.
didn't see those over there.
Oh, wait, excuse me 1 second. Give me 1 second, Mr. Roll. I'm sorry.
Oh, they got that one. You can stop right there.
What you just getting these?
Yeah, I didn't even, you know, Mr. Rose, I honestly, you can't see that very well.
What you ready?
So we might as well go.
Yeah, like, I have in contact, but. Oh, what? I didn't hold them in. I can leave my bag in the office.
Yeah.
It's really mad because I did it on grade. I've had friends in group that
What do you have to put? What? No.
Right, what?
No. What is this? No.
No, that's,
Oh no.
that's no with an exclamation
Yeah.
point.
So I see it now.
Okay, finish? Okay, let's move on.
I have them right on.
Okay, so question 3.
Oh.
I got that. I remember that and nothing else. So all I pass in this class, even if I never pass it, I just in my teeth.
The highest rate of is the third.
Oh, you mean Brainiac in the front?
Yeah.
I don't know about that, right? That's what I'm talking when I moved from here.
She passed everything.
Girl, I said, I'm gonna take the whole panel with my husband.
Elkin, this was, if you don't mind me saying, this is where you, I couldn't figure out why you did this the other way.
Okay.
I mean, no, I just wanted to, I want to know, you know, because this has a probability of actors at least 4, so you're looking for 4, 5, and 6.
I
You could-
got the first portion and I totally forgot the rest of the formula.
So, but wait, I get that right. You would know.
Yeah.
What do you say?
Yeah. And I got this, I don't know if you saw this.
What? Yeah, you did it. You got it right. Where you got this answer from?
I get that from calculator. That wasn't me.
So Mr. Rose, did
So
I
I did
get
it
this
right,
for
and I
B
get the
or I mean because I see you say rounding, so you
Yeah.
still decide.
Listen,
Okay, my
you,
bad.
you are
sorry.
trying to focus on what we doing. Okay, so we want 4, 5, and 6, right? So this is one you wouldn't do it the opposite way, because doing it the opposite way, saying 1 minus would mean that you this, right? Doing it the opposite way, saying 1 minus would mean that you got to calculate
Oh, I did it the other way.
0, 1, 2, 3, right?
Yeah.
0, 1, 2, and 3, and that's
Basically,
actually
4, 5,
more.
and 6,
So
and then 1, 2,
wouldn't do it that way. So, and then of course you already calculated 4, so that means you only have 2 to calculate.
Right at the
Right. So,
I didn't even think about that.
right, that's why I keep saying, when you look at these exams, think about the strategy, because if you have to think about how strategically you're going to answer the question most efficiently. This doesn't always you could do it. So that means we need a probability of 5 then, which is 6 factorial, 5 factorial, 1 factorial, 0.33 to the 5, 0.67 to the 1, which is 0.01573. And we need a probability of 6, which is 6 factorial, 0 factorial, 0.33 to the 6, 0.67 to the 0. So that's just going to end up working out to whatever this is, and that is 0.0013. So we have 4, we already calculated, so it's 0.0799 plus 0.01573 plus 0.0013, and that is 0.0969. So I just did this one and here 5 decimal places, because I didn't like the way it was. That didn't make a difference to me.
Excuse me, Ms. Rowe. That working there is for C?
Yes.
Mhm,
You needed 5 and 6.
Yes, the 5 and 6.
No,
So that's 4, 5, and 6.
Five and
The answer is right there.
Right.
Yeah, 4 was already there.
Yeah, so you're just using the same figures, just substituting for 5 and 6.
Yep, and like I say, just try to recognize that most in a lot of the questions, the part C and D, or at least the part D, will always use answers. Will tend to use answers from above.
Okay.
So there's no need to recalculate so many things.
I totally forgot that
Oh, I didn't know why I went
0.33 and
4, 3, 2, and 1.
the rest of the formula. I really
I know
that
this.
would just say
Because you see, I asked you a
Time
question, right? I asked you a question on there, right?
I was like, damn.
Because I think you got this part right.
Mm-hmm.
So does everyone else the rest? Like,
Yeah, you got ask one more.
Totally
Next
forgot
question.
that.
So what happened?
and then part D required you to calculate nothing. Part D just said then what is the probability of x being less than or equal to 3, which is really the probability of 3 plus the probability of 2 plus the probability of 1 plus the probability of 0, which is really then,
The opposite.
yeah, 1 minus the probability of 4 plus the probability of 5 plus the probability of 6, which we already have. So it's 1 minus 0.09693. So that is 0.90307. So Des,
Hey, which one?
any reason why this question should have taken more than 10 minutes?
Hey,
It's also-
No, I'm asking.
It's
I mean, now that you show it
No,
that way,
so-
honestly, no, because the answer was like right there.
Yeah, that's what it is. Because even on some people's paper, I kept writing questions like, why are you calculating these things you don't need? People are calculating things they have no need for some of these things they're calculating. Like, they see a table, and they go to the table, and they calculate all these probabilities in the table, but the question is, anyone asking you for anything from that table except to say that, like question 1, right? Question 1 just asked you questions about the table. It didn't ask you about any probabilities, and if people went and calculated probabilities with the table and all this stuff, why? That wasted 5 minutes, I'm sure.
One day I'll be there.
I just
That need to come quick.
So that's
I don't
question.
even know what
That
to
need to
say.
come quick. That's it.
So that's question 3. Let's go to question 4.
So Mr. Robert, you finish almost. See something. Is the last hand question three? Yeah, there was some points somewhere down here. Because I didn't get the first step.
I want to take my
Clear.
So, you know, this
That's
like
why I got the one idea. I said continuation of study.
I get it. You got to go to question.
Yeah, I did it.
Yeah, you should have gone to that.
I'll bring it back later.
I was just thinking about to make.
Yeah, I'll bring it back.
Okay. Okay, so question 4 now.
That makes more sense.
So question 4, they just said, okay, we'll take the classes. So class.
They got some of that, right, so that's 7.
19, 29, 30, 39, 40, 49.
I forgot to do the last part.
50. And it says, okay, what is the frequencies? BFI.
3, 2, 5,
7.
7, 3, 20.
And it says, what is the cumulative FI?
You could practice
3,
it at home.
5, 10, 7,
Oh,
That's what I did wrong.
that's what I missed out.
and then it says, what is the relative FI?
Oh,
0.15,
Point one.
0.10, 0.25,
0.25.
0.35,
0.35.
0.15.
1.
That's it?
That's what I missed out. Oh, that's why you put that question mark.
Just like the way you like it.
These are any reason that you're taking more than
Pardon?
Excuse me,
I should
sir,
make it more than
1
that
second,
minute.
please.
Yes, sir.
1 second.
Well, at least I get 7.
I mean, I should have set it up exactly that way.
Wow.
And I did it.
What happened was,
Oh, man. What in this soup thing?
Okay, the relatives.
Elkin?
chicken
The
sauce.
cumulatives.
Oh my God.
We have to
I should have said it like that.
Yeah, that's what's on
I
the
should have
This is
set it
relevant
like that.
cumulative.
Yeah.
And where's the frequency?
I actually put it.
What you
I don't know what happened, 'cause I actually did this.
I don't come back.
Mine too. HDR was last one.
Where's the frequency? Where's column 1? Where is it? I was
No, they had it. Yes, sir.
supposed to realize that that was
I was rushing to try and
5,
please you.
7, and 3.
But it's.
I was supposed to recognize that, right?
It's a frequency.
No, I'm making sure that, I mean, if you presented with that. I thought this was 70.
No, 7-3, sorry. But I put frequency right there.
Man, come
Actually,
on.
I have a problem. I do.
Come on, when I grade these things, I
You wanna
look at-
see it in
I-
your phone?
No, it's not in my phone, but I'm grading them, looking at
Clear
where
enough.
these things.
That's the
If I have to
vision.
go through, if I have to go through and sort of like figure out, okay,
fine.
she's trying to say this, come on, that's too much for me.
But that's how we have to review stuff.
Okay, I'll,
Thank you.
What is this now?
okay, so let's move on then, question 5.
Points, because my daughter had it. I'm your star.
Okay, question 5.
I got 8. I feel good.
You know what you get? I hate you, shut up. Step up. I don't want to do it again. I didn't tell Miss Mickey here.
Okay, so part A, what's the probability of 9 cars in 10 minutes when you expect 11 cars in 10 minutes? So the probability of 9, 11 to the 9 is 2.782 to the negative.
That's what I did. I go on half my 11. I don't know how.
Why?
I don't know.
In part A?
That was your question.
Yeah, that was
Part A.
But then the same thing was the same amount of minutes, that's why you didn't have to change nothing. And I remember that.
I remembered when we did one, each half the job. But don't worry, you can continue.
So it's probability of 6 cars in 5 minutes, so now the lambda changes. But it's going to be, what is the probability of 5.5 cars in 5 minutes? So the probability of 6 then is equal to 5.5.
No, it's not calculator. I can never get this and then
I mean, I don't want you to look, but if you.
the reflection of things.
I got the 5.5. I mean, look at that.
Here, this stuff.
I was wondering if we could even do it 5.5.
Yeah, I had 5.5, but see, I did it wrong.
I had 5.5, well, I get that. I got that.
We're not talking the veterans in here.
Oh, I see what I did.
That's
I
right.
used to the 10th power instead of 11th power.
I agree with you, Mr. Roll. Learn your calculator. That was me on the calculator. I did this
I had to get
same
it
question
together,
10 million times and I still couldn't get it.
See, Mr. Roll, I see why I got that wrong. I used the 10th power instead of 11.
I don't know what I used, but I mean, I couldn't get that. Even class, it was a challenge with this retarded calculator.
Okay, so yeah, that means if we want probability that x is less than or is greater than or equal to 2, so we're looking for the probability of
You should have given us in a group.
In a group? Why?
This week's too
Mr.
special.
Roll, yeah, what's the calculator? Because I have the same working each one, but the answer's like honestly wrong. Well, what a time.
So that means here we don't know what this is going to end, so we're going to use 1 minus probability of 0. So probability of 1.
How do you get the calculator?
So we don't have the probability of 0 nor 1, so go calculate
I
it.
go on that.
Okay, right now. You work on the project.
The 5.5, oh my god, I knew what I was
Mr. Rose said
doing.
there was no pressure because we had open book on, but I know. What I tell you about open book, I tell you if you had a big zero, bigger than that.
That's sweet, that's sweet.
Oh, go. I need you to do that thing for me, please.
I did practice.
I'm coming right back.
Slowly, Mr.
I didn't have a chance to rewrite. Next time I'm gonna try and write them properly.
Fine.
Probably get 60.
Yeah, the same exact thing, but just not same about I know that about.
Go there's your 5 point there. Go and look for your 5 points in there.
Don't look good.
I said look. 5 points.
I let myself down. I was thinking it would have been a breeze.
Sometimes you need a two though.
That's right.
Yes?
So when I say mechanical,
And then
Yeah.
if we kind of come to the exam, like, and deal with this mechanically, like, okay, that's it, let me answer the question, calculate, move on. It's like,
I can be honest, I let myself down.
I don't even know.
Because I was thinking that, okay, based on how we did the classwork, like that you teaching us and stuff like that, I came in here saying, and I got this because I knew it during the class. But actually reading the questions on here, I was like, okay, he can't help me no more. And I still can't figure it out.
so let me ask a question, what was the difference between this one and sometimes the ones we did in class?
No different.
Yeah, I mean,
It wasn't
because,
different, it was just, to me, the wording.
The wording,
way
that's
the
what I was
question
going
was
on.
asked is different, and that was.
Well, that's always
It's
gonna
not
be the
different, but
case,
it's just the
yeah.
wording of the question.
it's always, there's no two questions out can be exactly the
Because I
same.
sure I didn't answer it like this at all. Everyone else made it.
Mr. Roll, 1 minute. I don't know, I need to get a new calculator. Because look here, I was thinking of the same thing, but I see what I went wrong here. I
Yeah.
used pen and took away. The same thing, well, I don't know. It's the same exact thing.
This is part B.
My
You're not
answer,
using your brackets in the right place.
that's probably it.
Yeah, well,
Make
like,
sure
did the
this is
work
right
in
this time, so this is, all of this in
try it
brackets.
again and again, until like it doesn't make
Right now.
This calculator is good for, see this come and go and I took the beat, or you won't see all through the exam process, that's like, I got to
I
figure
said
that
to
out.
find out it's like
So,
all of this plus the
You only got about 4 more weeks to school.
If I'm weeks or
pretty
3.
long.
3 after today. Mr. Cargo still sending me emails
What is
about
it
3 or
now?
3.
Me too. And I was like,
He
I
says so
didn't class no more,
far
but thanks.
35 students have written the exam.
Whatever?
The key statistic, the mean is 72.9% and the range is 41 to 93%. Come on, you
Wait a minute. Put that as the guy don't just send an email in.
Yeah, that's what your problem is. You're not going to calculator. You need to put this in. You need to do
So how many students there?
I'll see how many
You don't need to
I
do
now.
brackets for the person. You do
That's
5.5.
one of them.
Raise to the
Four, six.
I went over
Two,
Last
one,
four,
two.
5, 6, 7, 8,
Times.
and
Times, open brackets.
But one of them we did because one of them was the bonus one. The rest we
2.8,
did
no, 2.7.
That means I get a 41.
Oh, that's why I have a zero in the middle there.
2.7.
I may get a 41.
2.718.
2.8.
Close bracket.
No, don't close brackets.
These are
Raise.
last 2 classes to graduate, and we said the 2.
No, 5.5.
I gotta take these on here.
Close brackets.
Close bracket equals There you go.
Divided by.
This class isn't difficult, you know. It's just that it requires time for you to focus. See, both of these classes require you time to focus.
Well, I used to drop that class. I couldn't.
Yep.
Oh, yeah, you
God, I need to work in the stand.
They're not
Let me tell
going
you
to
what to do.
your calculator.
Oh.
Just make sure you use your
But
brackets.
she needs to
Yeah,
do
but
is
did I not
write,
tell her?
write down
Brackets?
everything you just
Yeah.
did.
I was
say
trying to
brackets,
remember
everything.
brackets.
You hear me?
Brackets.
I use my brackets and this didn't work properly with the brackets.
should
I
put your
look
other
at- I
bracket.
But I use it now.
But I have
and
the
it's
same exact
working.
work, and I haven't.
See, I use it now and it's weird.
Write down what
Okay.
you just did.
So that's
So you won't
question
forget.
6. Wave 5, let's move on to question
I have
6.
begun again.
you can
do it.
over this
Oh,
again.
give me yeah, if it's going off and on, yeah.
But still write that
Mr.
down.
Rose,
Yeah,
should I stay
but I see where
discouraged?
you're wrong. It was 71828. I have 7180. Instead of the
Class,
working.
come back.
Okay,
I just wanna
so let's
cry.
move on.
Now that he's doing it,
On the top right there. Stop.
I could just kick myself right in the face.
I have it up.
I swear.
If you could kick yourself in the face right now, I give you full points. Oh,
Are you ready to try?
oh my god. I love to see somebody
I
kick
don't know,
themselves.
because I mean, like, how you doing it? And I have it, but the calculator just. I just
Mr. Rolla
didn't
is not
use it,
fair.
right?
Okay. So the question 6, right? Question 6 is a very simple question. Very easy. Most questions are got this right actually. Yeah. So
Oh no.
part A. I mean, in part A, you could do very many different ways. Just depending, you could use the tree if you want. You could use the table if you want. You could use whatever. When I did it myself, I did the table. A lot of people use the tree, so doesn't matter. Let's use the tree. So the first one is just it's just the education. So high school is 0.2. Undergrad was 0.7, and grad was 0.1. So the education was that, and then people who were in management, right? So you had to do management, non-management. So the probability that somebody was in management given high school was 0.1. And then you can do the other piece if you want, but it doesn't help you. You need it. Isn't it 0.1? Yeah. And then management and non-management. So the probability of management given undergrad was 0.4. And you can do the other one if you need it, or you want to, but you don't need it. And then the probability of management, non-management, and probability of management given grad was 0.8. So you just say, okay, well, what's the probability of high school and management? So that's 0.20 and 0.10 is 0.02. You don't need this because it doesn't help you. And what's the probability of undergrad intersecting with management? So that's 0.7 and 0.4 equals 0.28. Yeah, 28. And then this one, the probability of grad intersecting with management, 0.1. 0.38. So this is the probability of management. Now I didn't do mine like that, but I noticed that's how people did theirs.
Hold on.
That is actually
We get a .38.
What I did.
Which means you got it from Anissa?
Oh, Jesus, my bad. Sorry.
So because I did mine in a table, right? Because I think my brain is slower.
Oh my God.
Oh, for God's sake.
So
Wow.
right, so I do mine. I say, okay, well, what is the degree or what is the education?
I wish I practiced this more. I didn't practice.
And I said
Yes, it's even as I-
high school, undergrad, or grad. And I said, what is the prob of ed? So it's 20% chance that people had a right high school,
I had a 0.
70% chance that people had undergrad, and 1% chance people had grad school. And then I said, of these people, what was the
Monkeys,
percent
your slow brain works better than mine.
in management?
OMG.
And I said, well, there was a 10% chance that you were here, you
High
in
school
management.
diploma.
40% chance
Oh
you were
my
there, you were
Lord.
there.
You see this is?
0 and 80% chance if you were there, you were there. So, if you can and then I said, okay, so what is the probability of, ed
You shut up,
intersected
because you
with
didn't
math?
have a boss. You don't talk to veterans.
So just multiply the two. 0.0.
Wow, Mr. Roll.
0.
You should be doing 5 down.
So 0.38. So that's how I did mine, because to me that doing the table
That
makes
is
sense.
easier.
Yeah, going through that and having to try to figure out
Oh
where.
my God.
Because I really would have
Roll.
been upset if you didn't show me this way instead.
Mr. Roll.
0.36 that I'm close to 38.
I looked at that. I went back and I looked at that, and I saw why you got 0.36. Oh.
Did you see how silly it was? I
saw
had on the management. I didn't realize the
Oh,
question said
Lord.
10% and I had 0.
Yeah, I saw you made it little
I was
letters there.
Ouch. I go on to drink after
So,
a whole bottle of whiskey. I started on
Okay.
brandy.
And then, so-
That's nice. I like that.
so this was so you see, I mean, like this could, I mean, honestly, listen, I'm just trying to give you perspective, right? So when I did this on your table like this, it's like 3 minutes. I was like, boom, boom,
It's
boom,
much
boom.
better,
Mr. Rose,
Mr.
right?
Rose.
So
If you
straightforward.
see this like this, then I may actually be able to do it more.
Yeah. So,
I mean, this was like,
That is the truth. It's
Like
just
this one, I
if you
can-
match the answer to the question, this won't even take long. Just like,
right,
Oh,
so this is the
simple.
probability of high school intersecting with management.
I think statistics is just
Probability.
intimidating.
You overthinking.
something.
Get 80.
Probability of grad school intersecting with management.
Oh, I don't know why I get it.
So,
You could live. You? Veteran?
so that's part A, and then part B. Part B simply said, given that a person holds a management position, what is the probability that he or she has a graduate degree?
Common sense.
So, it was just that, so what's the probability that the person had a graduate degree, given that the person was in management? So what's the probability of the person holding a graduate degree?
0.08.
Yeah.
And over management, 0.38, 0.2105. That's it.
Oh, for God's sake. Oh my God.
I feel special in class. And I still started.
Not in a good way.
I have to sit to the back now. That's where I belong.
Okay.
This one fast, don't worry about it.
There's one.
Mr. Rowan, is our next quiz or midterm?
We need to push through stuff, and we need to get to chapters 5 and 6 and 7
We have
for the
extra
next
classes on
exam.
Friday. Are you
We could-
available?
Yeah.
I could come
Sorry, what happened?
Say again?
on Friday.
Okay.
I mean, you all can come.
Any questions here with question 6 before we
I was to
move?
work 8 o'clock this Friday.
No? Okay, let's move on to question 7 then.
No, my office is in shambles for 2 months. It's going to
So,
do nothing.
Yes.
When the next midterm have chapter 1, 2,
No.
3.
No.
He
Just
cut
5,
it
6, and 7.
wherever you left off from.
And they said we had a paper, right?
Yes, you're gonna get that.
So-
You're gonna get that paper next week, and then that's gonna be due at the final.
At the final.
At the final exam, yeah, that'll be due. You're gonna get it next week.
What's that?
The case.
Is it case?
Yes, 10% case.
What is the case?
Oh, we don't need to, do we need to do question 7?
Yes.
Yes?
Did we?
Really?
I trying to figure out why you put CV. Because, I mean, if I may ask.
Because it asked you for the score generation where
I got 3.
Oh, so what I didn't
I think it's
finish
seven
it?
and
Okay.
We can just do D.
I didn't finish. I'm so sorry.
Okay, I'll just give you the answers for it. I
There's
mean,
only C.
Okay, you can just give us the answer.
question
It was
7.
109.17. How did I get that?
S squared was 2, 9.69. 7.2. And C, CP.
Oh, down.
Right? It's that?
How the hell did I miss that?
I don't know.
Because I have A and B right there.
It's like the
What I
answers
missed?
say you just gotta use the answers for C.
No, but I
I have it
have.
in decimal.
No, no, okay.
Oh, okay.
Well, you know, and because it asked you to explain what it means.
Oh. So I lost 2 points?
Yes.
Man.
Asked you to explain what it means. I mean, that calculation can't be worth much. That's only, you already did everything up here. You just had to do a ratio, so.
I got that.
I missed the road. I don't know how did I miss. See.
Yeah, because you didn't know what calculate that.
All I got is that one part.
I left that part.
Okay, so let's do question 8 now.
So what the answers for C? I mean, and
As in every time, the thing what is it? What is it? What is it?
All you have to say for question C is that the standard deviation represents 15.59% of the mean.
Yes.
That's it. Represents 15.59% of the mean.
Answer the question straight now.
Because the interpretation of that usually depends on the problem.
realize that was so straight.
The standard deviation represents
Simple.
15
Of the mean.
Okay.
Yeah, because that's all you did. You divided the standard deviation by the mean to see how large the standard
No, I didn't
deviation
hear what you
is.
said mean.
Oh, yeah, compared to the mean. Okay, so let's do question 8. I'm going to erase this because I need to forward to question 8. Really?
Did you get it off the book? Anybody?
Sorry? What that is? Yeah, I'm on number 7.
So question
I
8.
had it right.
I have all the weekend.
I got that answer right. Yeah, you have to look at
So engagement and female wedding ring. So 0.7 for the engagement, 0.3 over the engagement,
They tried that too.
and then female wedding ring is 0.80. You can do, there is no male wedding ring here.
No.
Yeah, there is no male wedding ring here.
Yeah, that's the one
No.
you screwed up on. You know that one.
So
Done. I kind of
the
forgot.
probability of engineering intersecting with female wedding ring, 0.7, 0.8,
That's all I did.
0.56. Now, part B. Part B asks, what is the probability that a browsing couple is going to buy a male wedding ring and a female wedding ring? So, this one we have to be a little careful about. I mean, I know people say, some people got this right, but I think it might have randomly been that they were just multiplying things. And they got it right. No, I could see that from the way it was done. I've been doing this a long time. I can kind of tell when people sort of, okay, I understand this, because if they lay it out a specific way, it's logical. But if they just sort of throw two numbers there and it's written lightly, and they kind of just like that's what I realize that they're probably just trying something. So I've been doing that.
Mr. Rose, now I shut you down, boy.
I mean, honest, I'm just saying, don't take it the wrong way.
So
So-
I got a nice little squiggly thing.
Like a serious
I'm gonna
number.
point to the bottom of it. Darn it.
I got 7.
I tried it, but
So what's the probability of a female wedding ring and intersected with a male wedding ring, meaning that they bought both, right? So that would be the probability of a female and the probability of the male.
Yeah, which was 45%.
0.36. Oh, let me write it down, which is equal to
0.80 times
0.8 times 0.45.
45, yeah, which is
0.06.
Yeah.
see, I did
That was
0.55.
Yeah, but we
I
have to be careful
screwed
here
up
with
something. I
this.
did
Oh.
something wrong. Yeah.
I
I got the right numbers.
There was something.
Yeah, we have to be careful here with this.
Oh.
Because this question said that, unlike the first question, the first part of the question said,
They say assume independence, yeah. Okay.
right, it said assume independence here, because clearly they would not ordinarily be independent. So,
Right. I did not.
question 8 said, assume independence here. So, we have to be careful, because the problem here, that maybe most of you wouldn't intuitively notice, the problem here with part B, is that you have no independent probabilities, no intersectional probabilities in your question for when somebody can buy a female wedding ring and a male wedding ring. You might notice that, but that's the reason why you really can't complete this.
Okay.
I thought why it's
Right? There is no male wedding ring on here. It can't be.
That's why.
Because if you use the male wedding ring proportion, I think it was 45%.
Yeah.
Yeah, that's what I
Oh,
used.
right.
I used that, yeah.
So I went with what I see on information.
Yeah.
Well,
I used the
45%.
45.
I
and
looked at the
55%.
hamburger and fries.
Yeah,
That's
it's
how-
like that.
It's the same thing, so that's how come I.
It's like that, except this one.
This one's a little.
I
This one's a little different.
45%.
Part B here is a little different.
Well, lucky
Yeah.
guess.
So, the problem here, well, not the problem here, but what needs to happen here is you need to test this for independence.
I used 45. I don't know why.
And so that means that if you use the independence rule says the probability of A given B is got to be equal to the probability of A. And so for us then, that would mean that if you were to take this in the same vein, that the probability of female given male is got to be equal to the probability of female. And clearly these things are on two different planes, which is why this question has to be tested for independence. That's why I said I wouldn't have expected you guys to know that, so if you did this, I just gave you the point.
I didn't get it.
So the probability of female given male then is got to be equal to the probability of female intersected with male over the probability of male equals the probability of female. So if these things are independent, these two things should be exactly the same. So the probability of female intersected with male, 0.36 over the probability of male, 0.45 is equal to 0.80. Is it?
Yeah,
Yes.
it is.
So they're both independent, that's good. That's what this question is trying to get you to do, to test for independence, but like I said,
I include my, I don't know how I can include my.
Oh, so this you were supposed to continue with that 0.36?
yes, this is what we're going to test, that
Oh, but-
relationship.
Oh, so you still decided to give it.
Yeah, as long as if you did that, I said okay, because,
No, hey.
Yeah, they.
okay, and then part C, then,
Hold on, I don't know.
I'm not gonna erase that. Part C was fairly straightforward. So part C just said, engage, 0.70, 0.30. And then here for female wedding ring. So the probability of female given engaged,
I screwed myself.
this is 0.82. So the probability of female infected with or engaged is equal to female. Now this one I would do in a tree. I wouldn't forward a table here. This would be awkward because you don't have the balancing element in the table.
Mr. Roll, I also noticed that you had with had me a little bit off with this C4. I was like, huh?
No,
Oh,
that Dr. B. When we send the questions, I send my questions to Dr. B, or he sends them to me, whoever does the exam. We do our master. We tend to write C4, C3, whatever next to it. So we know that we've covered the chapter. So this was from chapter 4, C4.
Oh.
And he forgot to take it off the paper, that's all.
Oh, I like C4.
Yeah.
I almost finished this question.
So why we couldn't do the 3, whereas you had the diagram there, you have 45 mil, 55.
Where? Here? Oh, which one?
Yeah, right there.
Here? Oh, this one? Because he said that wouldn't balance the one, that's true.
Yeah. I know where I'm from. I didn't get it.
You see, and that's why I use, up here, the second trial, the second trial is not which wedding ring was bought, it was that, did they buy a female wedding ring? If they bought a female wedding ring, it's 0.8, anything other would have been 0.2, you see? And so it's awkward if you try to fill that in, because
Because I interviewed the whole
This
person,
role, I
I still
can-
don't
I
know
can
where
get
the
half a
80%
point.
came from. Because they said the customer browsed or did not browse. They either bought a female or a male ring. So I took it to be, you browse or not, and you
Right.
had 70-30, which is fine.
Uh-huh.
And then the other legs on both sides would be whether you bought a female or a male,
Uh-huh.
45 to 55,
45 to
which is
55.
100, right?
Doesn't the question say there's
Which
an
one?
80% chance that they bought a female ring?
That's what it said.
Yeah, 80% of those who browse purchase a female wedding ring.
And then they have in C where they said a chain purchase is 0.82%.
Right. So,
I put that 80 instead of 70.
what are you looking at here?
Oh, it says, while 45% of those who browse purchase a male wedding ring.
Right. So you see, that couldn't go here. See, because they're
I
not,
would have
they're not independent.
I took a higher sentence of 80%. I went straight to the 45. That's when I went 45, 55. So if the 80% wouldn't be there, you could still work it 45, 55?
Yes, if the 80% wasn't there, but that's why they specifically told you that the female was 80. And since the female was 80 and the male was 45, you clearly knew then that they can't be independent. They have to be dependent, but they asked you to assume independence here, which is why, yeah, you can't fill that in.
Trucks.
Some of these tricks is just following the rules. Just do what they say.
No, the 80% because it's down to what you expect to see. You expect to see a male or female working to 100.
Right. Exactly.
That's why I throw all of that.
Exactly, that's what you expect to see.
Right.
But yeah, that's why when I set it up, I said, no, we're only looking at, was it a female wedding ring or not?
I'm not.
Because it could have been a female wedding ring or a male wedding ring or nothing.
Exactly.
Yeah.
That's
Just getting used to the language.
Question number 9 right now, because I know we're pressed for time and we gotta continue on.
the bonus ones. Oh, you screwed them up.
Let's do question number 9.
Yes,
This question.
Surprisingly, I got 10 points for that.
I can tell you when I get
For
to
number
9
nine?
and 10, I was tired.
You got the whole point?
Oh, no.
I didn't percentage.
120 out of
I got A was 140. What B
Seeing
was?
you held me at 9 and 10. I was like,
No,
What?
what's that?
You get what?
Okay, so question number 9.
That's what arbitrary.
You said you were
Plans,
sorry.
What B was?
I'm like,
Engineering.
throw something in there.
What you
I
have
got the
there?
right answers.
I had numbers.
I think when I put
Very
one
raw percentage.
and see because of 9 is 9. It's like every time I see a shot on probabilities.
So question A said, what are the majority of seniors in the survey planning to attend graduate school?
You know,
And you just, I mean,
I just said no.
you just say no, right? No.
Now the CID.
So 260, 260
Oh, really?
come on planning.
Oh, I just put okay.
I put no and I put only 140. He will be attending.
Yeah, that's fine. I just took it the other way.
Right.
okay.
Okay, that was right.
C is like
Engineering.
So I was right the first time, screwing up myself. Oh, I didn't. I'm so
See, I really need that.
But I had others. Oh, I can just go on the chart that he's asking me what I did.
But these were presentation, comment on the relationship.
Yeah, so people did many things here, right?
Yeah, I didn't
So, but I
get
was
that.
just to calculate the row percentages. So compute the row percentages and comment on. So the row percentages are either yes or no, right? Those are
The qualitative.
row percentages. So what percentage of people said yes they were going to grad school? Percentage of people said no they were going to grad school. And if X percent of people said they were going to grad school, what does that mean? If X percent said if Y said they were not going to grad school, what does that mean? So whatever your explanation for that was, okay, there's no right answer there.
I just got a line through, I don't know.
Let me see. Was that a squiggly line? Oh, because she wrote all this stuff, I was like, okay. I was like, this whole page.
Nonsense.
No, I just
See
okay.
what we do, just the probability of the
Well, yeah, just calculate the row percentages for yes.
For
what
business, for
percent?
engineering and others.
What
No
yes
for
or no?
yes,
Oh,
point
yes or
three
no.
five.
And then
for
no
no,
is 0.65.
0.65.
So you say yes, these students will be attending, and no, these students will not.
Right, but if 65% of the students said that they are
Not
not
attending.
attending, what does that mean? That since the majority of students are not going on to grad school, therefore one can presume that a graduate degree is not considered as important by these students.
Okay. All right.
Right, something like that. But it
Okay,
doesn't.
I see.
There is no right
or wrong
answer. It's just like one explanation that's logical.
Understand the problem.
Right.
But Mr. Well, I did some things.
Well, I did
Mr.
write
Ross,
notes, like,
also,
say, want to attend
I
graduate
had
school.
mentioned to you that I did do the work
You at
in one
least get a
meeting,
partial
no?
point for that. I got a point
But
for my right.
I did do the work in, but then I
Squiggly
didn't get
means
no
writing.
point.
Because you did it.
I told you, Mr. Roll, I said, Mr. Roll, I did the work and I know I did not complete C. I said to you, I know I didn't complete C, but I did the work and hopefully you'll only give a 1 point for that.
Who was all that working?
I did the,
Who was all that working? You did all this working on this table, and the thing only asks you.
Mr. Roll, you can't give it all the points.
Yeah.
Okay, let's move on. Let's move on. Question 10.
It's 58%, and for
Yeah. So question 10A. 2000. B.
Wow, I
58%.
can't take it.
C. 4%.
Mr. Rhodes, I know true. That is not true. Oh my god.
I got it right.
I'm always amazed when you give
But my
questions
dummy-
like that.
It'll simply go
Here's the
on
thing, you
and
asked
just
me
be
what I was trying to say,
weird,
right?
big
I have
things.
58 and 4 out of 2,000. 58% and 4 out of 2,000.
Okay.
That's what I was trying to say.
That's
That's what I was trying to say.
When you do this, you really have to set this up so that I mean
So you
seriously.
could understand.
I didn't read this. I didn't read this, Mr. Roll. I did not
And
read
he said
this.
C is 58 out of
2,000.
percent.
We say 58%.
That's not 58 out of 2,000%.
Mr. Roll, I did not read this. Had I have read this, I know I would have figured it out.
You see why we can pass the class, right? And if you
You
don't
give me a
pass,
point and
you
take
can
it
pass
back
the
to class.
You deserve what?
I need the point.
Okay,
But I didn't mean that.
so that's question 10. So bonus 1.
My lord.
Yeah, this one. Mr. Rowe, what happened here?
I tried this.
Because I thought this
I
was
think I
nice
did this
and
wrong.
easy.
I
It
did
was
at
very
first.
easy.
I was like,
So
yes.
bonus 1 simply said, what is the probability that x was greater than or equal to 10?
Can't be 0.2.
So in what cases were x greater than or equal to 10? So it was the one where it was
10.3.
where it was 10. Where was the probability of 10?
10.
The probability
my
of 10.2.
God.
2 and 10.6.
Probability of 10.6.
Wow.
Which was equal to what?
2 plus
0.2
3
plus 0.2 plus 0.2.
Oh my
my
god.
0.2.
What to
And
confirm?
then
That's not even funny. Like, seriously?
it's not, I know.
Oh
And then
lord.
so it says now for part B, what is mu? So, let's put a
The
percentage
expected rate of return.
and the prob. So, 9.5, 9.8, 10.0, 10.2, and 10.6. Probability 0.1, 0.1, 0.2, 0.3, and 0.3. We know this has to be 1, right? And then and so it's asking you for the mean now. So it just wants to know what is the mean rate. So it's just that times that, plus that, times that, plus that, times that, plus that, times that, plus that, times that. Gets divided by whatever, divided by the total, and it gives you, so mu is equal to 10.17. Now, let me say this. Because some people did this, and when they gave me an answer, they gave me some huge number. If you can see that these were the percentage rates, right? The average return can't be 50%. Your average return has got to be somewhere in here. Got to be somewhere around these numbers.
I have
I started to do
attend that
B.
one.
I
Because I
got
say
one.
you want
I
a
did
lot
that. I
of
get a point for that.
stars.
I can get 1 point for just getting equals 1.
Now you know.
And I got
That's the same.
50.
Would you
That was
believe me?
me.
With Mr. Allen for college math, he had a simple one answer question for 25 points, and them said they wrote half a page. And when they saw my paper, I had 2 lines. Elkin, you got the 25? Yes. Well, how did Mr. Allen said, don't mind the points. That was just to throw you off. That's how it is being.
Listen, I
I
just
know
need
you already
to
did.
pass. Purchase.
So that's it. And then
Now he wants some sort of
And
big
then for the
number,
standard
and I didn't know what
deviation,
the heck.
well, that's for the standard deviation, right?
Wait, I
So-
don't even know why I do the rest of them.
So what is x minus x bar? We already have x, right? Minus x bar times, and then, we can either do, this one can be done a multitude of ways. But we say, okay, what is our individual x values? B is minus x bar, then just square it, right? So what is, I don't have it on my paper, so you guys have to give it to me. What is this minus this and square it? 9.5 minus 10.17 squared is what?
9.5.
0.95?
Minus.
Take 9.5, subtract 10.17 and square it.
Negative 0.67.
Can't be negative.
No, that's
Square it.
point
That's
4489.
Say 9.5.
Yeah,
So
And with
9.5
0.67?
take away 10.7.
Yeah, that's what he said, 9.5.
Yes, just
minus
do x minus x
10.17
bar.
equals,
Take this, minus that,
and
and
then
square it.
square it.
And a
that's
square it.
negative
All you want is square it.
0.67, then square it, he said.
0.44.
Yeah, 4489. I said that, I was scared.
0.4489. Okay,
Yes.
9.8 minus 10.7 squared.
Yeah, 0.1369.
10 minus 10.17 squared.
0.2. No, 0.
0.0289.
0.0289.
Yes.
9, yes.
10.2 minus 10.17 squared, you're a tiny number.
0.009.
10.6 minus 10.17 squared.
Oh, there's another 0, sorry, there's 3 zeros in that.
No,
3
that's
zeros,
not
okay.
that one. Point 1849.
1849. And then we want the probability of x times x minus x bar squared. So just take this column now, multiply it by the probability.
Two zero.
What is this times 0.1?
0.04489.
Give me 4 decimals.
0.0449.
9, right. This times that, that'll be 0.013 0.2 times this is what?
0.0058, something like that.
Yeah, 0.05. 1, 2, 3,
How many
7,
zeros?
8. 0.0578.
0.0578, 0.0578,
Yeah.
0.3 times 0.0009,
0.0003.
and 0.3 times 0.1849.
0.0555.
Add them up.
Zero point 1722.
0.1722?
Yes. I don't know.
No, no.
Oh.
So sum that. So this is the, so now take the square root of it.
Zero point 414. No. 0.4150. something.
0.4149. I mean, it'll be 15. 'cause six is-
4150.
Yeah, 4150.
Okay, 0.1722, 0.
Okay, this is what it says. 0.41496.
0.414.
Nine. So we don't change that to 50 then.
No, I'll be rounded. No, okay.
That's my problem at all that.
Doesn't get to round it off.
Okay. And then bonus 2. Okay, so bonus 2, I'm not going through this in detail because this is just using it from your textbook.
Okay.
I mean, you guys didn't even, when you guys did this, whoever people who did this question, I mean, didn't even use the group main question. This is group data. You can't just calculate a standard deviation. You need to use the procedure that in your textbook to calculate this. So X bar from group data, it's 276 divided by 4.
I thought that was the only question I might get right. Zero.
S from group data, S squared from group data is equal to 3. S from group data is equal to the square root of 30.22 by 0.54.
Mr. Rowland, if I may ask, how did you get 276?
Listen, go to your textbook
Okay.
and use the procedure for these group data problems. Okay, I told you all when we were doing this, the class, that the things that come in the bonus are going to be things in the textbook that we did not cover in class. So I don't want to spend too much time because that's quite a long procedure. So go to the book, do it. Make sure you get those answers. Come back. You don't. Yeah.
Okay.
What about that objectives?
What, that?
Yeah.
Oh, okay.
Thanks.
All right, now let's see if we can move on. Time is it. We spent way more time on that. We should have to. Anyway.
We really thank you.
Yeah, no problem.
Appreciate it.
Okay, so now we need to try to get to chapter 6 today.
Mr. Rowe, we should see all of this back on the final again.
Not all of it.
Not all, but I mean, I guess
Yeah.
a few
But
of
you
them.
should, yeah, definitely. Things like binomial and Poisson always come back to the final, and sometimes standard deviation comes. Sometimes, depending on how.
I guess you just
Where
be
you
really
get
careful the questions carefully and see what it is.
Yeah, and you see one of the things I like. One is I would say about this first exam. And I think this first exam always
It's a wake-up call.
points
Yes.
out. Always points
Because I
out.
mean, like
What
how
you
you
need
did
to
that,
work
that was,
on.
I was like,
The most.
seriously, for that question now, you just say 2015, 4%, like,
And it always surprises me whenever we put those types of questions on the exams.
it's like we be
The answers are right there.
Yes.
If you remember the one with that one, that other question with, I think we did it in this class with, where it said like 89.3% of the people went to high school, and we did that question in this class, I
You
think,
know how to do the calculator?
and like
That
I
was
don't
on the
know.
last quiz.
that was on the last quiz, right?
Actually,
Yeah,
that was
actually,
right.
the
I got that
last
one
was on
right.
the two.
Right. And you know, and even questions like that, right, where you only have to say, oh, it was just 89.3%.
Yeah, you just write it out,
Or was it-
work it.
People always be like, what am I working out?
No,
What am I
that's
working
just take it,
out?
that's just too easy to be the answer.
Right.
Yeah.
But sometimes it is. Just like in this case, there were two questions here where really you just had to go to the question and write down the answer. So just be careful that you read the question and don't overthink it.
That's what the problem is, overthinking.
Okay, so let's move on. Then we're going to do continuous probability distributions today.
Chapter 6.
Yeah.
It's 10.
Today's the 8th.
Okay, so in the for us the most important continuous probability distributions we're going to be talking about there's a uniform probability distribution, the hypergeometric, the exponential, and the normal distribution. Now, uniform, hypergeometric, and exponential are extraordinarily simple. We're not going to be trying to cover that in the lecture because we're going to waste lots of time on those. They're very simple things. Just please make sure you read those elements of those sections of the chapter and you practice problems there, because things like that will tend to come up on the exam in the bonus, right? But what I want to focus on today is the most highly used and the most important of all the normal continuous probability distributions, which is the normal distribution. So we're going to be talking primarily about the normal distribution today. So this thing that we call the normal distribution, it is really a family of distributions, okay? And I know when we were talking about Poisson and binomial, we were talking about families of distributions. So when we talk about families of distributions, Helga, we talk about families of distributions, we're really talking about an infinite number of possible outcomes for these distributions. Meaning that for the binomial, for example, we said the shape of the binomial distribution really is dependent on n and pi, right? The number of observations in the data set and the probability of success. That really tells you how that distribution is shaped because it gives you a mean, right? N times pi gives you the mean. And then for the Poisson distribution, the Poisson distribution again is a family of distributions because the shape of the Poisson distribution really depends on its mean, lambda, right? So that means then that lambda could be anything. So since lambda could be anything, that means that the shape of the Poisson distribution could be anything. Since n and pi could really be anything, the shape of the binomial could be anything. It just depends on those things. The normal distribution is even more so the case. Because when we're talking about the normal distribution, we're talking about distributions that look anywhere from something like that to something like that and everything in between. So if we consider this the most extreme case where everything in this distribution, not everything, where most things in this distribution are very tightly packed around the mean, right? You have these very, very tightly interwoven things around the mean. And maybe you have one and two things, maybe one or two things in the tails. This means what? That if you look at your grades, for example, and try to apply your grades to something like this,
We're on the right.
right? You try to apply your grades to something like this. This means what? That, let's say the mean was a 50. And you had some people clearly who did better than 50, and some people who did worse than 50. But this distribution is saying, oh, everything is so tight in here that everything is very close to the mean. There's very few things that are very, very far from the mean. This person here got a 5, this person here got a 95, right? That's very, very, that means that everybody else was kind of in here. If this is the case, where everything is tightly packed around the mean, what does that tell you about the standard deviation of this distribution?
It's very small.
Standard deviation is very, very small. So we would call this then a low sigma normal distribution. Okay. Now, on the other hand, over here, the mean is still going to be 50, right? But in this case, notice how flat and wide this is. So you're going to have situations where this is kind of happening. Right? Right. So, yeah, so look at this. This is really kind of telling you what? That, hey, I have a very widely dispersed set of observations, right? A lot of people are clustered in the tail, meaning a lot of people got, in the 10s and 5s and 20s and so on. Not very many people close to this mean on this side. And then when you go on the other side of it, not very many people more than the mean. Not very many people right close to the mean on the right side, but lots of people out here in the 80s and 90s and 100s. This is going to tell you what? That you have a very high standard deviation in this distribution, right? So we would call this a high sigma normal distribution. And then somewhere in the middle, right? Somewhere in the middle, you're going to have this very nice, this beautiful curve where the mean is still 50, but you have all of these wonderfully distributed things like this. It's all random. And there are some people that are close and some people who are far. And this is really the way we expect grades to look, to be honest. This is what's expected, this normal distribution, right? So the mean is still 50, but you expect half of the class to get below 50, and you expect half of the class to get above 50, right? And you expect somebody to get a 0. That's expected. You expect somebody to get 100. You expect somebody to get an 80. You expect somebody to get a 90. I mean, not an 80, a 10. Somebody to get a 90, and so on and so on, and everything in between. So all of these things are nicely sort of spaced out, and it's all pretty and whatnot. This then, we're going to call this one the standard normal curve. Okay? Now, here's where the problem is. Stop focusing on writing this. This is in your book, right? Don't get too carried away with writing this. Because I'm not spewing anything new here. Trust me, this is all given to you in your textbook. What I want you to understand here, though, is why we're going to go into this whole section, right? And what makes this standard normal curve important, because this is the thing we're going to be looking at, standard normal curve. We know that this exists where things are tightly packed around the mean. We know that exists where things are widely dispersed around the mean. And you know what? From here, if you consider this the most extreme case on the left-hand side where things are most tightly packed, and you consider this the most extreme case on the right-hand side where things are very widely dispersed, there's an infinite number of possibilities in between. So you can imagine this coming from here, kind of going down like that, right? And that continues to go as an infinite number of these curves. We, just like we did for binomial and we did for Poisson, we would have to try to figure out which one of those curves apply. to our scenario, depending on how large the standard deviation is, right? Depending on the size of that standard deviation, we're going to figure, should we be using this one? Should we be using the one just right next to it? Should we be using that one? Or is it really down here? And then, so now we have to go through this whole process of figuring out which one of those curves to use and how high it is and how wide it is. We don't want to do that. We do not want to do that. So, for us, then, what we are going to do is we are always going to use this standard normal curve as our proxy. All right? We're going to use that as our proxy for all normal distribution problems.
So can you
That's
combine
the
all
main
of them on one?
They are all going to be combined in here.
Yeah, that's what I mean.
Yes, they are all going to be combined in here. But in order for us to do that, we have to then also do something called standardizing data. Okay? And how do we standardize this data? We standardize this data by calculating z-scores.
See what?
Z-scores.
Right. And these z-scores are calculated by z is equal to x minus mu over sigma. Or, clearly if you're using a sample, x minus x bar over s. Okay?
So the z-scores would be all of what's in the, because you said we're calculating the
Yes.
z-scores.
Right. So that we can get rid of this. And so that we can get rid of this. Or like Shakira said, really so that we can get all of them into one standard curve, we have to then standardize our data sets. What we're going to try to do now is to say, listen, we don't care whether or not the standard deviation is low or the standard deviation is high. We don't care what the standard deviation is. All we want to be able to do is take any number and be able to pinpoint on a standard curve where that number is. We don't want to know whether or not it's on that side and it's small or it's on this side and it's big. We just want to know where it is on any standard curve. So, in order for us to do that, we have to do this. Now, so let's take these two away on either extreme. Alright. And let's say now that we just look at this z-score model. What does that tell you? It's very simple, right? Only three things. It says take x, subtract the mean, divided by the standard deviation. So what is that doing? What is that doing in effect? That's taking the difference between the actual x value in the data set and the expected value of that data set, which we call a residual, right? From chapter 3, we're calling that the residual, divided by the standard deviation. And what does that do? That tells you, well, I know that dividing it by the standard deviation does one thing, because we have done this with Chevy Chev already from chapter 3, right? I know that by dividing it by the standard deviation tells me that I have to have a number that fits this curve. And that number that fits this curve can either be on the left-hand side if the number is smaller than the mean, or on the right-hand side if the number is higher than the mean. So the z-score then can be a -1 if it's up to the left of the mean, or a +1 if it's on the right. Or you could have a +2 or a -2, or you can have a +3 or a -3. And anything in between. Meaning that I'm saying 1 and 2 and 3, but it really could be 1.67 and 1.35, 2.89, 3.09, whatever. Okay? But the point is though, that once you're able to calculate these z-scores, that's actually quite distracting. That light? Yeah.
Oh, the light on.
Yes,
Yeah, the
it's
light
like
on.
it's on.
Oh, I didn't flash that.
Yeah. So once you're able to calculate the z-score, what this tells you then, brilliantly tells you, I mean this cuts out so much work that you would have to do if we couldn't do this. What this brilliantly tells you is that any value in your data set, any number that you choose at random in this distribution, is assigned a location on this curve based on where it is in relation to the mean. So I can express any number on this curve in terms of its location on this curve in relation to the mean, but expressed in standard deviations. So let's say I grab a number. I grab some random number and that number happens to be here. So I'm going to say, I don't know what that number is. I don't know what that number is. I don't care what that number is. Makes no difference to me what it is. But what I do know about it is that that number is 1.53 standard deviations to the right of the mean. And since I know that number is 1.53 standard deviations to the right of the mean, I can then figure out what that number is. And not only can I figure out what that number is, I can tell you how significant that value is in this entire distribution. So that's what the beauty of being able to standardize the values are, meaning that you don't have to worry about the infinite number of curves, you can just use this one. That doesn't seem critically special to you guys, I know, because you've not been through the practice of actually using normal distributions without standardizing data. But I trust you. No, I assure you. For those of you who have to go on to 301, when you have to do that, you're going to see why this is so important. Yeah. So
We have to do 301.
Stats.
well, for those of you, I don't know.
That mean us? No.
If sometimes COB students take the class here,
If
but
it's
they have to go on. Yeah.
No, for the previous.
No.
Okay, so let's look at an example.
Stats 301.
301. Oh no, I heard people drop that.
So let's go.
And
Stats 301 is actually easier than this class, to be honest, yeah.
Just so the foundation.
Let's look at an example. A very simple example, and then we're going to go to some more tricky things.
We're
because-
rated?
Yes. Because let me just say this too. This whole section on continuous probability distributions and the standard normal curve,
It's gonna be.
this area here requires tons of practice. This curve, sweet as it is, it's cute, it's cute as this is. This can be so problematic if you don't understand all the intricacies of how this curve looks and how it
We're not
works
gonna do it
and how
simple.
it fits and how you have to manipulate this and turn it upside down, inside out, all this stuff you'll be able to do with this, so that you can find a number on that curve on a whim. I say to you, 1.735 standard deviations, you gotta go tell me the number right away. But you can only do that if you're very, 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 very familiar with the way this curve works. Okay, so we're gonna try to do quite a few questions here. First one, easy question. Well, maybe, let me not do that one. No.
Oh, Gregory and Mara today.
No, we're gonna do that one either. Do that again.
Tashi wrote copy on her she ended up being studied in. 10 years. And 3 kids later.
Just find a good question. Oh, yeah, this one. You don't want that one. I want to find an easy one to really get you guys started.
What did you give us an easy and a hard one?
Okay, I'm going to use this one. I didn't want to start
Yeah,
with this
hard one
one.
because that's the ones you can put on the test.
Okay. Example. The mean cost for, I'm going to try to, this is a long question, I'm going to try to abbreviate it a little. The mean cost for employee alcohol rehabilitation programs. The mean cost for employee alcohol rehabilitation programs. Involving hospitalization. For a particular company. Is $10,000 a week? With a standard deviation of $2,200. Assume that the cost of hospital stays is normally distributed.
You said hospital stays, right?
Part A. What is the probability that a rehab program will cost at least $12,000? What is the probability that a rehab program will cost at least $12,000 per week? Okay, so this question is a fairly simple one, right? What we're going to do with all of these normal distribution questions. Okay, we're going to do with all these normal distribution questions is we are going to establish a procedure for the way we lay out these questions and the way we answer them. Okay, this procedure is not going to change. And this procedure is to be used whenever you have to answer these questions, because there are a number of little parts here and we want to make sure that we don't miss any of the parts. Okay? And also this starts to set us up for chapter 9, because chapter 9 has a very long procedure for some things. Okay? So part A says, what is the probability that this rehab program is going to cost at least $12,000, right? So now they expect the rehab program, so that's not right. They expect the rehab program to cost $10,000, right? Because they said the expected cost of a weekly stay in a rehab program is $10,000 with a standard deviation of $2,200. So they expect it to cost them $10,000 per week. But they want to know what's the probability that it can actually cost $12,000 or more. So they say now we know it's a standard normal curve distribution, a standard normal distribution problem, because it says assume that it's normally distributed, right? So first thing we do then, we establish what the probability is. This is the probability question. Next thing we do is we calculate the z-score. So we want to calculate the z-score for $12,000. Have we already said that we know z is equal to x minus x bar or mu over s, right? This is a sample, so we're going to use that one, but you could use the other one as well. It's fine. So x in this question then is what?
10,000.
Sorry, 10,000.
X. What is x in this
X is
question?
10,000, or is it 2,200? They're not standing.
Yeah, they have 10,000 per
They
week.
have
10,000. 10,000.
But less than 12,000, so it can be 12.
Okay.
Minus the 22.
10,000 greater than or equal to 12,000.
Okay.
You said X greater, right?
I'm asking what is x for the problem. We know.
12,000,
Who's that? 12,000. Why 12,000?
because that's the,
Yeah, they say at least.
The amount they ask you.
Right, because that's the random variable. That's the thing that they're asking you to try to
Okay.
find. What's the probability that X is $12,000 or more? Right? So that's going to be $12,000. What is X bar?
The 10,000.
And what's standard deviation?
2,200.
Okay, so what does that work out to be? $0.91. Okay. Now, these z-scores, I am asking you people to stop
to write.
writing. Stop writing, because at the end of this, you can only be asking me questions that you can answer because you're not following what we're doing. I'm going to give you time to write this down. Okay? I mean, I don't know why you guys try to focus so much on writing when we need to understand. You could always write this. So these z-scores, when you calculate them, you must always round them to 2 decimal places. Okay? Because what's going to happen is when we go to our tables to look for probabilities associated with these z-scores, they are always the 2 decimal places.
You erase them.
Yes.
You erase.
Oh. Okay, so we find our z-score. Next thing we do then is we plot this on our distribution. So we say, okay, here is the mean. We know the mean is always going to be in the center of the distribution.
Okay.
Now the z-score. The z-score is 0.91, right? So what does this z-score 0.91 tell us? This says that $12,000 is 0.91 standard deviations
To the right.
to the right of the mean.
Okay.
So,
Because it's positive.
yes, because it's positive. If it were negative, it would be 0.91 standard deviations to the left of the mean.
So I mean, is it 12,000?
Mean is $10,000.
10,000, sorry.
Right.
Yeah.
So since we know that the mean is $10,000, we expect then $12,000 to be on the right because $12,000
It's more
is
than
more.
10,000.
And we expect, if it, let's say this were 8,000, then we'd expect
To the left.
To the
to be on the left because it's less. Okay? So $12,000 then is 0.91 standard deviations to the right of the mean. So that means the $12,000 is right there. Now, let's stop there for 1 second and talk about this distribution. When you look at the way this distribution is shaped, okay, it is clearly I'm not drawing it perfectly, but this distribution is supposed to be symmetrical, meaning that exactly what happens on the right-hand side should happen on the left. Exactly which probabilities exist on the right-hand side should exist on the left. That's why I drew that nice little normal standard distribution curve, right? It said that everything is sort of distributed the same way on both sides. That means then that the problem doesn't care. Really, it doesn't care what side of the distribution you're using. Okay? The problem really doesn't care what side you're using. What it does care about, though, is where this number is in relation to the mean. So, when we go now and we look at the probability question, and we look at where the z-score falls, we need to make sure we know which direction we're going to look in on this curve. What do I mean by that? This says, here's 0.91 standard deviations, right? The probability question said what? I want to know the probability that X is going to be a number that is at least this. Right? So since it wants to know the number at least this, that means that it's looking for which portion of the curve? Everything
On the
from
right
here.
hand side.
To the right.
So it's looking for this. What is the probability of this happening?
My God.
How do I find the probability of that happening? Well, it's very simple. How I find the probability of that happening. I know that the probability on this side of the curve has got to be what?
50%.
50%. Because like I said, anything that happens over here, and since this mean falls directly in the middle of the distribution, 50% of the possibilities is going to happen on that side. 50% of the possibilities can happen on this side. What is the possibility?
Less than.
What is the possibility of something happening on the mean? What is it? What is the probability?
Of it happening
Of a
on
number?
itself.
50%, eh?
Listen to the word. Listen.
No.
What is the probability of a number happening or falling on this mean? Zero. Because 50% of all observations has to happen on the left,
if
50% on the right.
yeah.
And we've proven that, right? Because when we calculated means in this class before, in distributions we've calculated
Right.
means. What have we always said about that
It
mean?
has to
That
be
means
zero.
zero. Less
No.
than, no more than one.
Yeah.
What have we always noticed about that mean when we calculated the mean? That mean number,
0.7.
don't guess. Think about it, think about it. When we've calculated means in this class, we did a problem with people getting on an elevator. We did a problem with somebody buying their what?
Or the
Refrigerator,
bags,
something, right? That average price of that refrigerator, that average weight of the person getting on an elevator. What did we notice about those average prices and those average weights? They never go. Those numbers never existed in the actual distribution. Exactly. So we kept saying that this mean is an expected value, but it never actually happens. So the probability then of something happening on this mean is zero. Which means that 100% of the observations have got to fall everywhere other than on the mean. So if that has to happen, then that means 50% of all possibilities has to be here, and 50% of all possibilities have to be there, but not on the mean. Okay? So, yeah, so that means probably something happening on the mean. I think you said it right? Was zero, was nothing.
Yeah, I said 0.
Yeah. So, knowing that, then if we know that this side of the distribution is equal to 50% of all possibilities, and we want this, if we could find that, then certainly we can find this.
Okay.
Right?
Correct.
Yeah.
That would it be the, I don't know by fast, but 49.9, would that be the difference, go to the 50?
No.
Would you subtract it?
No.
We have to go to the thing.
We're gonna go to the table.
Okay.
So here's what we're gonna do. Go to the back of your textbooks. So for those of you who have,
It's in the
those
front
of you
for
who have the
some.
hardback books, they're at the front, right on the hardback cover. And I want you all to find this, and then we're gonna talk about this for a second. All of you have the hardback?
Yes, sir.
Hardback 10th or hardback 9th? Go to the front. Go to the front. Go to the one in the front.
Yeah, go to the one.
How's the one in the back?
Go to the one in the front. Yeah, there's one in the back as well, but we won't use the one in the front. So, since those of you, thank God, all of you have
Could I just use
the
this?
hardback 10, the hardback 10, right?
Yeah.
So, yeah, this is where they started that. Everybody has the hardback 10. Hardback 10. Okay. Okay. So here's what we're going to do. There's a little procedure we have to go through here because you guys have the updated version of this table, which is which in this case is actually not a good thing.
That's what my friend was saying. She
Yeah.
had the other book and she was trying to give it to me.
So what I would suggest, I suggest that if you can get your hands on one of the older, same version book, but like the edition just before it,
Yeah.
copy the table out of that, or go online and download the previous version of the table, or we can subtract 0.5 from everything in the body of this table. Okay? We can do one of those three things. Today, clearly, since you only have that, we're going to have to subtract 0.5 from everything in the body of the table. On the left-hand side of the distribution, the negative side that you have there, we are not going to use that at all. No matter what your number comes out to be, if it comes out to be negative, we are not going to use the negative side of that distribution. Okay, that is going to create problems for us in some of the questions to come. So we don't want to do that. So what we're going to do then, I'm just going to walk you guys through this. Some of you have not used this before. Yes, I recommend putting an X through that, for real. So the Z table looks like this, right? So 0.0 and 0.00. Then it goes 0.1, 0.2, go down, 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 0.8, 0.9, 1.0, 1.2, 1.3, 1.4, 1.6, 1.7, 2.5, and so on and so forth. That's how it goes, right? If there are two decimal points, there are two decimal places. I mean, there's a place before the decimal and then a place after. And then up here you have the two decimal places after, right? So 0.0, 0.01, 0.02,
0.03, 4, 5, straight to 9.
Okay, so that's what you have up there. So what we're looking for here is a Z. What you have here is a Z-score, right?
Right.
This is the way this table works. You have a Z-score, and so here is the Z-score. So this is 0.91. So this is 0.9 and 1. So
okay.
Oh, that's different.
right. So this is 0.90, 0.91, 0.92, 0.93. Okay. So this is the way this table works.
Okay.
Now, in the opposite way, this table also works. Meaning that if somebody tells you what this area is in here, you can find the Z-score by taking that area, looking in here, and going to the Z.
Okay.
So you could use, it works both ways, okay? And we're gonna need it to work that way for some questions coming.
Okay. So in this case, you're working with the Z-score.
Yes, you were given the Z-score. You calculated the Z-score.
So, and
But
don't forget
if
it said
the
minus
opposite,
5.5.
then it's something like that's probability is 0. Whatever. What is the score?
Sorry.
I'm trying to see like what question will let you go in the table and find the
Yes.
Z-score.
Probably if the probability is blah blah blah, what's the Z-score, whatever. It might not ask it that exact way, but you're gonna see some problems we're gonna do now where you can find it.
Okay, so you said we have to take 0.5 from the body. So it'll be the 0.8186 minus the 0.5.
That'll give us 0.3186.
3186.
So that means that this is 0.3186.
Okay.
In between that little
That's
section.
in between.
Right.
Okay.
So the table is always giving you the probability between mu and
And
Z.
that's what I was just going to ask you because I thought it was the blue space,
No.
the 0.91.
No. The probability, the table is always going to give, read the top of the table. It says.
Yeah, I see.
Yeah.
Entries in the table give
Under the curve.
the area under the curve to the left.
Between the
Of the
mean
Z
and the
value.
Z
Okay.
standard deviation.
Alright, okay.
So we want this.
Okay.
You're able to get this piece here from the table.
Okay.
So how do we find out what that is?
Minus it.
So we say, okay, this half of the table is equal to 0.5.
And
Subtract this piece here, which we don't need,
from 0.5.
0.3186, and that's equal to what?
Negative.
Negative
0.1814.
0.5 minus 3,
Oh, I believe
0.81814.
18, 14.
1814. So that means then this is 0.18.
So if we add those up, we should bounce back to 0.91. No.
0.5.
You took 0.5 and subtracted that.
Yeah.
So if
So
you
it told
plus
you that the probability of everything happening underneath this curve is this.
Okay. All right.
Okay, so everything underneath the curve is the probability of X occurring.
Okay.
Okay, the probability that an event is occurring is happening
Oh,
in
so
the
you
curve.
carry back to the 0.5.
Probability that X is happening happens in this body.
Okay.
In this body.
Okay.
Okay.
So the 0.5.
So I have a
Makes sense.
Yeah, because when you want the deep circle,
This side of the distribution is worth 50% of the possibilities. 50% of things can happen here. 50% of things can happen here. Right? We're not doing anything on this side of the
Right,
curve
it
because
has to
everything's
equal out to
equal
the
on the
point
side,
five at the end
right?
of the day because.
The reason you have to subtract 0.5 from your probabilities in the first place is because these new versions of the table,
Are not correct.
no, they're
No,
not
they
correct.
only minus the.
They're correct, but
0.5.
they've done something different. They've said, rather than giving you the probability of this half of the curve, they've given you the probability of all of this.
Oh, so we have to find the difference.
So you want to take this out because this is
Right,
messing
right,
with you.
right.
You don't want to
Okay.
use this. This has nothing to do with you. Okay? And that becomes even more critical in some of the problems that we're going to do a little later.
So Mr. Rose, will we ever have one where it's not 50-50?
No, it can't be. It has to. That's the
It
curve.
has to be 50-50.
Right, the curve is always
Okay.
going to be 100%. Everything, this curve represents 100% of all
100%, okay.
possibilities.
Alright.
Yeah.
So Mr. Rowe, I have a question I still don't follow. We say on the table, we're gonna take away 0.5. But now to find that probability, we're taking an extra 0.5?
Listen, you're doing two different things
Oh,
here.
that's
The whole time
You're
we
trying,
equal one.
you're trying to deal with the table first. Dealing with the table is just to give us the probability. Taking the 0.5 away from the table is just to deal with giving us, allowing us to work with 1/2 of the distribution. That's what we want to do. We only want to work with 1/2 of the table. We don't want to work with this full table, which is what which is what the that particular version of the table is giving you. The whole thing. We don't want that.
So no, the reason I asked is because we didn't, well, this is semester, so it's short version of the lesson. But on the prior class, you have like, if it follow within the one standard deviation is 64 or 32%. If it's two, then we on the 3 standard deviation from the mean, which is 0.95, which is the
Right.
0.5 is taken away for that reason. right?
No, so you're taking 0.5 away, not 0.05.
No, 0.5, which is the 5% that, like how the table, I mean, the book has it. You have a tired, however you.
Yeah, you have from here to here.
Right, so you have, within one standard deviation from the mean, you have a percentage, I think it's 68.
Yes, but that's you, right?
So when you get to 2, you have something different. When you have the 3 standard deviation, you have the 95% coverage.
99%.
So that 0.5 was the extra outside of that probability.
For the 95%, right?
So that's what we're doing here.
No,
No, okay.
no, we're not doing that. We're not doing that. There are 2 things that you're doing.
No, I got what you're saying.
Right.
That is because of the malfunctioning of the table, not the standard table. You're gonna do the 0.5 and then we go through this.
Right. So once you take away that 0.5, which would mean that this area over here is just 0.3186. Then you say, okay, since I know this whole thing is 0.5,
Yeah.
right? This whole thing on this side is 0.5, and I'm only looking for that. Then if I know this, I just subtract that from 0.5 to get this piece here.
So if you don't add up to 0.5, then we wrong. No, the 50%.
Well, yes,
Yeah.
yeah.
So it should always add
Yeah,
up
yeah.
to
always add up to.
0.5. Okay.
That's what I checked back.
Yeah,
But
that's
that's how
when
I
you
needed
add
to
to
understand it.
0.9.
Okay,
Because
Right.
see, that side is 50%, so anything we do, gotta come back to that.
Yeah,
Right.
come up with
Yeah.
0.5.
Okay, so that's part A. Part B,
Straightforward.
part B says, what is the probability? So this this is 0.31.
What is the probability?
What is the probability that a rehab program will cost at least $6,000?
So that's less.
Probability the rehab program will cost at least $6,000.
Yes, yes.
So much you said, okay?
At least $6,000.
Equal or greater than
So-
6,000?
So the probability that a rehab program will cost at least $6,000. So with this one, it's asking the probability that X is greater than $6,000, right? That's what it's asking. But
Put it down or equal to it? My bad, sorry.
I'm saying something, right? The question is saying, what is the probability that the rehab program will cost? So what does it say?
At least.
At least $6,000,
Yes.
right? So even if this problem said it was going to cost more than $6,000, meaning that that's what I wrote, right? More than $6,000. There is nowhere in the normal distribution curve that you can do this. You cannot do this. You could do this with binomial.
Yeah.
You could do this with Poisson,
Yeah.
but you cannot do this with the normal distribution. Only because the normal distribution has no idea what is more than $6,000 unless you tell it where $6,000 is.
So where to start?
Okay.
So you have to know where to start. So even if the question says more than 6,000, you
So
have to
it's always
assume.
like assume at least.
Yes, you have to assume at least greater than or equal to. And the opposite way as well. If it says less than 6,000, you have to assume less than or more. I mean less than or equal to. Okay?
So you should always assume at least.
When it's least, assume greater. When it's greater, assume least. That makes sense?
If it says
If it says
this,
just least
that
or
means this. If
Yeah.
it says that means that.
Okay.
Yeah. But if it doesn't tell you, well, we assume.
what if you do it as a trick question? You just
Yeah, and then you want us to do the old-fashioned, like.
Okay, he's gonna give us the answers right now.
Like to work it out the other way with a poison.
But then the question would be Poisson. This question is not Poisson. If a Poisson question says to you the probability that x is less than 6, it wants the probability the question that the probability is less than 6. If it wanted it less than or equal to 6, it would tell you that. In this case, it is saying I'm saying that no matter what it tells you, if it tells you less than or equal to, if it tells you less than, I mean greater than, you have to tell it where to start.
Okay.
Unlike in Poisson, Poisson doesn't care if you, Poisson cares if you say this or this. Because it knows where 6 is. It knows where 5 is.
But in this case, it just doesn't know.
In this case, it doesn't know where greater than 6 is unless you tell it where 6 is.
Okay.
Okay? So, don't change the Poisson and binomial rule. That's the way it is. It's only here that you have to make sure that these two things are
I just
considered
hope
the
when
same.
that somewhere down the line you point us to the C-score, to the something that I know is this and not the other. If you
I
know what I
was
mean.
going to ask you that.
What do you mean?
When we read the questions,
If the question says, what is the probability that the rehab program is going to cost more than $6,000? If it says the probability is going to cost more than $6,000, what are you going to do? What are you going to do if it says the probability that the rehab program costs more than
But I could
$6,000?
assume that it's at least
No, that's
and go
not.
straight to the C-score. Oh.
no, that's not Z-score. Because Z-score says at least.
No.
No, you
Z-score
say
can say,
assume.
the Z-score can say the probability that a rehab program costs more. Even if it says cost more, where is more? Where is $6,000 for you to tell it? Where is $6,000 for you to tell it? This is more than $6,000. You have to first tell it where $6,000 is.
Okay.
So I'm saying, if the problem tells you this, if it says more, you have to assume that it's greater than or equal to, not just greater than.
Okay.
If it says less, you have to assume that it's less than or equal to, not just less.
Okay.
So, in everything that's discrete, you can count 1, 2, 3, 4, 5, 6, and you know where 1, 2, 3, 4, 5, and 6 is. Here, this is continuous.
Yeah.
So, even on this curve here, where I put my pen, I can't say that that's 6.
No.
I can't say that that's 6 specifically.
Proof that that's 6.
I guess because right there where I put my pen, there's an infinite number of
Yeah,
possibilities
in
underneath
between.
that dot.
Yeah.
So I'm going to say, you know what? Right here, that's where 6 starts.
Okay.
And so that's why even if it tells you I want more than 6, you can say, okay, even if you want more than 6, I'm telling you 6 starts here.
Right here.
Okay? So don't get them
confused if I know,
confused.
okay.
Yeah, no, don't get them confused. And
But
because we're gonna have to go and do
key
something.
elements you're gonna give us, because like in this case you tell us like how you tell the standard deviation, like certain element will.
Listen, all these questions are different. It's possible you might get the standard deviation, but you might have to figure it out. Okay. This is the easy problem. Let's not complicate this one.
Yeah.
Okay. So, right. So probability that a rehab program is at least $6,000. So we go to Z then. So you look at Z for $6,000. So
$6,000 minus 10,000.
minus
So
10,000
$2,200.
over 2,200. And that's equal to, should be negative 1.81.
Yeah.
Yeah.
Okay.
So 82.
82?
If you round it everything.
Yeah, you have to round it to 82.
8.82.
Okay. So next thing, plotted on the distribution. So there is mu. So this is negative 1.82. Now, when you guys
It's
do
on the
this, yeah, it's gonna be on the left hand side. When you guys do these, you know, don't try to say, oh well, negative 1.82 has to be right here. Put it on the left hand side. Okay? Don't think, oh, it has to be right here because that's where negative. You don't know where it is. Usually.
No.
So just put negative 1.82 over here, and then say
And take
that's where we take
And
it up.
shaded anyway.
Now, what part of this distribution are we looking for?
the least.
The middle part between
Oh,
0
between
and
1.82 and mu.
1.82. We're doing 0 and 1.82 first.
Behind.
Well, when you say first, what do you say first?
Between where 0 is and where 1.82 is first.
Why you say first? You saying first,
That's just what I would do.
and then do what then?
And then subtract it from 0.5 afterwards, 50%.
No.
What are we doing wrong?
Look at what the probability is asking you. What is the probability that X is greater than or equal to $6,000? Okay.
Should you do
need
the-
to stay-
should you do-
need to stay.
Yes, 1
What?
point. I come right back.
Okay, so you were wrong. It's still supposed to be on that side because it's supposed to be more than or equal to it. So it stops there. So we still have to look for that same part. The part that I said first.
So we found the
Yes.
point of where
Yeah,
six
so it's
is.
right.
6,000.
So this is where
So we
6,000
still
is.
need to just find just that part itself.
Right. So what do we?
6,000.
So this is where 6,000 is, and we ask for the
That's
probability that it is at least 6,000. So where is at least 6,000?
Right there, 1.82, negative 1.82.
Yeah.
And where?
And before. I mean,
Back, eh? Going back.
well, 6,000, it'd be.
This is $6,000. Where is everything that's more than $6,000?
This way to the right.
This way.
Going by mu.
So, but you keep
Go
saying
towards
this.
0.
Going towards mu.
No.
To where mu is then.
No. No.
To the right.
It's greater
Let me
than
ask you. Let me
6,000.
ask you guys this
Like
question.
any number that increasing on this or
And so where is
To the right.
everything that is greater than
To
6,000?
the right.
To the right. Where?
To the
Everywhere.
positive side.
Including
No, no, no.
everything.
including
On the positive
On the positive side. Oh, okay.
Including everything on the
Including
positive
everything.
side.
Okay.
Because if you're trying to find 14,000, isn't $14,000 going to be over here? And isn't that greater than 6,000?
Just speaking.
So it has to be everything.
To the
Okay,
right.
all right.
Oh, okay.
That's what you were asking us. Okay.
Everything. And so now,
I have a question. So now we're gonna
Let's
say
go. Continue, sir.
no, go ahead.
those.
Once we finish finding everything in front of there, that's more than half of it.
Right.
So then we have to find for both halves first,
Right.
and then add it up. Okay, all right.
Yeah.
Okay, never mind.
So
Okay.
now
So-
we're going to 1.6.
I actually think it makes sense.
So we know that this area in here then is 1.82. So we go to our table and look for what this number is in here for 1.82. So we're looking for 1.8
See what number you
and
use.
2.
1.8 and 2 is 0.9656.
4.9. Oh,
What?
no, yeah. Sorry.
0.9656.
Take away the
Oh.
0.5. We're only looking for half of the distribution, remember? So we're going
That's
1.82.
0.4656.
0.4656. 656. Okay. So we know then that this is equal to 0.4656. And we also need this half over here, which is equal to what? 0.5.
Okay.
So the probability then that X is going to be a number greater than or equal to $6,000 is what?
0.9656.
Right. So it's going to be this 0.4656 plus 0.5000 equals 0.9656. Okay? Which is what your table told you it was. This particular table told you it was because this table is using both sides of the distribution. That's the number it gave you in the first place. Right?
Right.
Yes. We don't want to do that. We do not want to do that.
Just plot that number there because we see it.
Yeah,
We
we do
need
not
to,
wanna
we
do
need
that.
to do it. We need to actually work it out.
Yeah, no, we don't wanna do that.
So coincidentally, it work out like this in this case.
Yes, because
or
you- because
anytime
it-
you have a negative.
No, not anytime you have a negative, it depends on where it falls. You see? And so what this table is requiring you to do is
what
use
it's
too many
asking
rules.
Yeah.
Here, if you only use half of the distribution, there's just one rule. The rule is always the same. It is find the area between mu and z, and then look at the direction that you're trying to find. Either take the direction, if the direction is this way and this is over here, clearly you have to add those two. But if suppose this was like that,
If it was less, then you
That's
then
just
you can
just
subtract that and get
Yeah.
that. You
So we
see?
just do 0.5 minus the 0.4656
Right. If you just needed this piece
if
here.
you need that.
Yeah.
less than
Yes.
6,000.
So you see, the rule is much simpler if you only use half of the distribution.
And the order in this case it would be 0.4650 minus 0.50 means you're still gonna have a negative number because you
No.
go further down a bit.
No, your probability can never be negative,
It's the probability itself. that
right?
you're
It can
working
never be
on.
negative, so you're always gonna just say, I mean, that's why I keep saying,
For the sake
the
of
problem doesn't
working,
care.
I
That's
can always
just
do
the Z-score.
0.5
That's not
first.
that's not the
Yes.
answer. Yes.
Yes.
Other than that, you tend to confuse if I put the 0.5 in other place, it
Yeah.
can become a negative number.
Yes, but and then you know the probability cannot be a negative number, so,
This can be used with
okay.
you know things like a job.
Let's do part C. These questions tend to have, these normal probability questions tend to have quite a few, like 3 or 4
3 or 4 sections.
parts to it, sometimes even 5. So you have to try to work these quickly. These can take long if you gel on them too much. Okay, so part C. What is the probability that a rehab program will cost between $8,000, cost between $8,000 and $12,000.
So therefore we need to know
Good.
the already
Good that you noticed that. Great. So let's
I get the point.
So we need the average of them
let's do
first.
this.
So
Oh,
8,000 and 12,000.
So you do P open bracket X.
So now you want between
Yeah.
8,000 and 12,000.
Is that the
So
equal
you're gonna
sign?
say
No?
8,000.
And the
So we
cross
average
out
it
is
first?
No, we already have 12.
Right.
Okay.
So we gotta find 8,
So we
right?
say
Come on.
So what are the question? What was the probability that a dealership would what?
I trying to figure what sign do we use now? I mean, it wouldn't be less than or greater than.
between
But
8,000.
the equal and
So we're trying to find
X.
probability that X is what? That X is.
Is
Put 8,000.
more than
So right, put
8,000.
8,000.
Or 12,000, whichever you choose. And then X
Okay.
is
close bracket.
between.
Close
Less
brackets,
than
and
Between
12,000.
12,000.
Okay.
Okay.
So what do we do next?
We need to find what 8,000.
Just find 8,000.
Let's find
This
C
is
for
where 12,000.
8,000.
Z at 8,000
Probability of
equals 8,000 minus 10,000 over 2,200.
is greater or
And we
equal
get
to
the next
8,000.
topic. 8,000 minus
That's minus
10,000.
12,000 over 2,200.
That's negative 0.91. Got that answer for something? For 12.
Yeah, for 12 because
But
the
it's negative,
difference.
this one
Right, that
negative.
one was positive, right? But the
Yeah.
difference was just $2,000. So
Yeah,
it'll be the same
okay.
stuff like And then we need the Z for
12,000.
which we already have,
Yeah.
which is
0.91.
positive 0.
Sorry, yeah, positive 0.
Good. So what do we do next?
We have to graph
Plot.
that on the table.
Plot it
Plot it.
on the distribution. Yeah. So that's distribution.
So we gotta do the negative 0.91 and the positive 0.91.
Negative
Yeah.
0.91.
And then we do that for the same side too, that line.
The positive
Yeah.
0.91. And what are we trying to find?
Oh, is it shaded in between?
The in between will be those two bars, yeah.
Aha.
Jeez, I actually catch on something.
So now what do we do?
now. We gotta
But we already
find-
know what 0.91
Yeah, but
is.
yeah, 0.9. We already know what that is.
And what is it?
0.186.
86.
So 0.3186. So what is this one gonna be?
Yeah, we find that.
Negative. You have
Negative.
to look for it first. I would say negative 3.86, but that's not true.
Then on my report.
0.91. So that's 818. It's the same thing.
It's the same
Yeah.
It's the
thing.
same thing. Oh my god, I was right.
That's why.
But
Why do you
yeah.
have to be like that
That's
though?
why. I keep saying
Yeah, it's the same thing.
The table, as long as you use
So will it
this
be a
rule,
negative?
as long as you use this
No.
rule, the table does not care.
Change. Oh.
It does not care if the z-score is negative
negative
or
or
positive.
It was the
Whatever
same
happens
thing.
on one side
Happens
happens
to
on
the
the
other.
other.
Oh, yeah, you did
But
know
it's
that.
back in the,
That's-
Yeah.
that's a times in the middle of the 8,000, 12,000. Or is that
Yeah.
X?
Time.
Was it times?
Negative 8,000 minus 10,000.
No, that's 8,000 minus 10,000. That's a number sign.
No, in the tip, in the thing on top.
On
P
top is
equals
8,000.
Oh yeah,
Multiply.
This is not multiply.
that's X.
What is the
X.
probability that
X
X is a
is
number?
equal.
X.
That's
Oh,
between
okay.
8 and 1,000. Yeah, that's X.
Okay.
So it's 0.3186 on
Right.
both sides.
But then even if you don't want to assume, which you could assume because you say what happened to the right happened to the left. You could just work it out again. You go to the table
You could
and
do
do the
that.
same.
That's gonna waste
Do you
30
get the
seconds
same-
of your life.
Yeah.
I've had it.
Your
I did
phone
like
is
for
gonna drop.
comfort.
Your phone.
It's
It's
gonna
gonna drop.
Okay.
Right?
So
But,
then we get the
right.
same 0.184.
So what is the probability then?
0.184.
Writing
I'm trying to figure out how to get this off of this thing.
0. Point,
1814. Sorry.
what do you?
No?
No.
You know what I'm wrong. Oh, I took away the 0.5.
Listen. Look at what the probability is asking you for.
some years.
Between 8,000 and
50 minus
12,000.
31.96 times 50? No? I mean
Look,
times 2?
you guys are trying to make this
Just add it.
so
So
It's
difficult.
zero, right?
You are trying to make this so hard,
It's 0.
right?
You just add them.
You are trying to make this so hard. Where is, it says, what is the probability X falls between this and this? Where
Add
is
the 2.
this?
Oh, we add the 2, 0.3186.
Negative 0.
That's this, right?
Yeah.
Where is this?
On the other
Positive
side,
minus
positive,
This.
okay.
So what is
So
the probability
0.
of this then?
It would be just 0.
Why is it 0? Why?
Because they net up.
Can you
Because
tell
that's
me
where
it's
they meet. That's the average of
31.86
both.
plus 31.86?
It can't
times
fall on the
31.86?
line of you saying it can't fall on the line of mu, but I call it mu.
Okay, let's
Right.
see what we
So,
did
okay,
here.
oh yeah,
fall.
it can't fall minus 1. So you have to do 0.5 minus
It
both.
Yeah,
can't
it
fall.
can't
And
fall on
then
the
add
line.
No, Jesus. No.
No?
No, we
Why are you
already
all
had
trying to make
this.
this complicated?
So the answer is 0 then?
Listen, y'all stop talking.
Okay.
Y'all stop talking for a second.
So let's go on this one.
Y'all stop talking. Stop talking for a second. Stop. Okay? Look at this distribution.
Right.
The distribution is very simple.
Yes.
The distribution says
8,000.
everything on one side is equal to 50%,
Yeah.
everything on the other side is equal to 50%. You found the probability of everything between mu and 0.91.
Yeah.
Mm-hmm.
You found everything for the probability between mu and 0.91.
Okay.
Now it's asking you for the probability that X is going to fall somewhere in there.
Subtract
Did I
from
add the
100,
2 probability?
Why are you subtracting it from 100?
Because we have the full scope of the chart, eh?
Yes, but you're only looking for this to this.
But it's 0
Then find
because
the
it can't
average of
fall
it.
between on the line.
It's 0 because it balances.
It can't
out.
fall on the line
Yeah,
and it
so-
balances out, like she
It's
said.
not, where is the negative?
On the left.
This probability is not
Never negative. Oh, you just add them.
Oh,
You just add them.
I see, I
Just
see.
add them.
I
All
see,
bad.
I see.
All bad. All
And I
bad.
tell you
This
this
probability
too.
is not negative.
We're special.
This.
Just add them. That's it.
Very. Today.
That just say that
Fairly.
8,000
Right there.
falls here and the
12,000
12,000
falls
falls there.
there.
And what I want is one
Okay.
in the middle.
What's
Yes.
in the middle?
So my question to you is, do I add or multiply those two
Why
numbers?
would
That's
you
it.
multiply? Why would you
So that's
multiply?
0.6.
I'm trying not to
Six,
answer the
six.
question
I'll add it.
directly because I want you to think about it, right?
I will add it.
Yes, you have to just add them.
0.66.
So this says
I
that
said 31%.
this says the probability that the thing is going to be from here to mu is that,
Uh-huh.
and the probability is going to be from mu to that is that.
Right.
These numbers could have been different, right?
Yeah.
Exactly.
This one could have been 0.91, this one could have been 1.44. Doesn't matter, you would still do
Have the
what?
same.
Just
Just
on
add
0.66.
So you're looking for,
But
yeah, I
that
know
was
you was,
my problem. That was my problem. I thought it was still negative and it can't be negative. That was my one problem.
Yes.
But I just said just add it.
probability cannot be negative.
My bad.
Mr. Roby can get it, you know, you can be proud of us.
So
One day.
0.2186
Mhm.
plus 0.3186 is equal to what?
0.66 if you going to that.
6372.
We going straight up? Okay,
6
6.6. 0.6372.
Seven.
It's 4 decimal places.
Yes. The z-score, you must round to 2 decimal places
Okay.
because this only has
Two.
2 decimal places.
Okay. But that wasn't difficult. I mean,
Bear with us.
We're sorry. That was awesome.
Once you
Apologize.
realize, we would never think like you.
Don't rub that off.
I
Don't
need
rub that off.
something, I need maybe some
Great,
stuff
great,
on
great.
What?
Espresso
Mr. Roy, don't
works.
do it. This one wasn't bad until we go to something else.
Yes, and we ain't get to this, we ain't get to the difficult things yet,
Oh
so
my God.
There's worse than this.
this is
This
nothing.
is easy
Yeah,
compared
this is
to what's coming
straightforward.
up.
Give us like 5 or 6 of these.
Give me 2 of these
this
and then
only
give me
getting
the hard
warmed up
ones. Give me
for
the
the
hard
stuff.
ones now.
Sorry?
I know, I'm trying to get there, but this problem should have only taken us maybe 10 minutes and we already been on this for half an hour. Half an hour we've been on
It's
this
the
problem.
lamp.
Robert, let's go.
This is where it is.
I want the hard one because I know
just
it
write
was
this
on the
down,
test.
right?
And I can't afford to fail.
Let's go on to
Again.
part D of the question. This was part C, right? This
That was
C.
part.
This was part C.
That was part C.
Yeah, so let's go on to part D.
Go, Candy.
Guys, you think
I mean, I'm gonna WhatsApp one of my friends and ask if he could beat me for a drink after.
No, man, Mr. Roy.
Don't go away.
Come on, man.
I just
Please don't meet me up Sunday.
You can have a
Don't
drink
worry.
Saturday,
Don't
just
be
don't blame it on us.
Hey, don't be a Sunday porter. That's my sport.
Where?
Because that's where I should be drinking first.
Twisted line
Between Twisted, Anthony,
and spritz.
and Circa, I will be
Okay.
one of those
Okay.
after this.
When you guys can meet up.
Part D says,
Yeah, we drink.
what is the probability that a rehab program will cost between $6,000 and $8,000?
When you done have sex, I mean, figure it out.
These
Yeah.
are working pretty good now.
Yeah, Emo?
Yes, sir.
Okay, you can do this one.
I'll put 6,000. Less or equal. X. Less or equal 8.
Okay.
Good girl.
Mhm.
We're gonna do the one for, we have the 8 too?
Yeah, just
Z's.
the procedure, let's follow the procedure. What's next?
Z of 6,000.
Do you have that already?
No, we have greater than. We have to work that out.
Did we calculate?
We
the
have
C for
6,000.
Yeah.
6,000 is negative 0.91.
But I have
No.
X
No.
is greater, oh, we said
Negative
the
one.
left.
No, negative 1.82,
1.8
sorry.
is alright. We had greater,
Oh,
we
I
put
thought
to
8,000.
6,000.
Huh?
We had the probability on B that X was greater or equal.
Right.
That's the
We
opposite.
have answers
So
for
we
both
just
of
need
these.
to
It's a-
It's the same thing.
Question is, do we have a z-score for
Yes,
$6,000?
we do.
Yes.
Yes.
1.82.
Yes, we do.
Positive.
Z score.
You're trying to make this difficult, you know. You are
Okay,
trying to make this
I'll
difficult.
just
I'm sorry,
listen.
I have it right.
I'll just
Yeah.
listen.
1.82 plus the 8,000 you paid.
0.64.
What is the z-score for $6,000?
1.82.
1.82. Negative what?
Negative.
Negative 1.82. Negative.
Because that's what
Isn't that what you calculated?
Yeah, we got
Yeah.
negative.
Yes, sir.
Negative 1.82.
We didn't do
The
1.82.
last one was.
We did 8,000.
What is the z-score for $8,000?
The z-score of 8,000 is
0.64.
0.91. Negative 0.91, sorry.
Minus 0.91.
Let's plot the distribution.
So
Where
we
are
go
these things?
to the left of mu.
So that's fine.
Negative 1.82 is there.
Six.
Negative 0.91 is there.
Okay.
Right.
What do we do next?
Just add it.
Everything this
In between.
so
In between.
in between
What are you trying to find?
Negative point.
from the blue straight over to the far
Let's say
right.
from 6,000. That's
Look
1.82.
at what you are being asked to
Between
find.
the 6 and the 8,000, the what, negative 0.82 and
And
negative
0.91.
0.91.
Right, so
That's
this is what you're being asked to find, right?
Right.
It's just that. So, what is the area then for negative? Well, what is the area then for 1.82?
1.82 is 0.4656.
What is the area for 0.91?
0.3186.
So what are we looking for? Just this piece in here.
Yeah.
So what do we have to do? Subtract what from what?
0.4656
From the 0.
from 3.1.
And the difference is.
And what is that?
I'm 0.147.
0.0147.
147.
So we shouldn't take, like you said, we shouldn't take long with this because if we answer question 1 right, then you should answer question 2 right. I mean, because you would already have the figures you would already.
I mean,
calculated.
sometimes.
cases.
Yeah, in some cases, the question like this,
It could
they
flow.
will tend to give you. They'll tend to give you things like this that you've already calculated. You have to find different elements. Like this one is looking at both of them on the negative side,
Negative side.
right? The other one was looking at it from 0.91 to 0.91,
Mhm.
right? So all these things you're trying to do is test that you understand how to manipulate the distribution. Right? You had something on the negative side, something on the positive side, which means that because they're falling over there, you need to add that,
that,
right?
okay.
Because you're looking for the
But
thing in
because it
between.
falls to the far left, which is negative, you have to subtract.
Because both of these are on the negative side, right? Both of them are on the negative side. You have one that's at 1.82 and one that's at 0.91, but you only want what's in the middle, so now you have to subtract because you only want what's left in there.
And if it was on the other side, it would be applied, but it would be addition.
Which mean it was on the other side?
Let's just say it was a positive 182 and a positive 0.91. And we wanted to find the difference in between them again. We would add it because
Why?
it falls on the positive
Why
side.
would you add it? You're still looking for
It's
this
still
piece
the
in the
In the
same.
middle
middle
there.
there, yeah.
That's the only thing
Which
you're
would be
looking for.
positive. Because it
It
don't
does
matter.
not-
Whatever you do,
Okay,
whatever
just the one
right.
right. Oh,
So
right.
especially
Okay.
if it falls on the
I get
whole side of the
confused.
mu.
Yeah.
If you do this
Yeah, the
side.
probabilities don't matter. The probabilities
Okay.
don't care if it's negative
for
or positive.
positive,
The only
just
thing that
fine.
cares, the only thing that is that
The point.
cares if it's negative or positive is the z-score, so you know where it is.
Okay.
So
That's what I was getting a little confused. I was like,
So right, so this would be exactly the same, right? It would still be 0.4656. This would still
And
be,
this is
0.3.
and this would still be 0. But it's holding at 0.4656. And this is 0.8186.
Okay.
You want that, so subtract that
from that.
from that.
and
But you
you
go to the
assume
left,
that
you go
it's
to the
never
right.
negative. So if you come with a negative result, then you do the opposite, right?
Say that again.
Just go back to what we were saying, that the probability is never a negative number.
Uh-huh.
So if you subtract 3186 from 4656, you get a negative number.
Oh, yeah.
You've done the wrong thing.
Yes. Yeah.
Also, if it asks you, this is just not part of a question. The question D was saying the probability that the rehab program will cost between 6 and 8. If it says less than 6, we just do 0.50 minus those two, right?
If it says less than 6,
Right.
if it says less than 6 and this is 6, right?
Right.
So if this is 6, you only want in here.
Right.
You found this. already.
Right.
So you subtract that from 0.5 to give you this. Yeah.
That's what you said.
The sum of the two minus the 0.5.
Mm-hmm.
No, with some of the two. But I mean,
So 0.5 minus all of that.
you could say the sum of the two, but really, this is idiot. But yes,
We
but no.
complicated it.
Don't do it like that. Yes, the answer to that is yes, but because this is already in this number.
Uh-huh.
You see, this is embedded in that, isn't it? Because this is from here to here.
Oh, okay.
And that's
See?
from there to there.
See, that's important
Yes,
to
but-
know because I was gonna do that wrong. So I just take away 0.5 minus 0.4650
Yes,
because
exactly. Because this is already in that
A
number.
part of that number.
see, step to
Look at that.
You see, look at that. Almost the same.
Okay.
I would have added those two.
I would. That's what I wanted to make sure. 4, 5, 6, and this
Let me see if I can find another question.
Maybe like Maggie from the
Okay,
Simpsons.
let's do this one. This is going to step this up a little bit. Okay? Well, you know what? Before we do that, let's do another one. That's not so difficult.
Make time long.
Okay. Alcon Laboratories uses highly specialized refrigerators.
Laboratories uses highly.
Specialized refrigerators.
To store fluid samples from patients. Gia, are you still there? She's lost.
She may have it on mute.
Just
Hold on.
fluid samples.
From patients.
The fluid samples can survive only within relatively narrow temperature ranges. And the laboratory expects the interior temperature of the refrigerators to be 38 degrees Fahrenheit. With a standard deviation of 1 degree Fahrenheit. Alcon chooses a refrigerator at random. What is the probability that part A the temperature will be at least 40 degrees Fahrenheit?
At least how much?
40 degrees Fahrenheit.
40, at least 40 degrees Fahrenheit. Okay, let's start with you. Let's start with you. Shakira, let's start with you. And we're gonna go around. First part A.
We'll do P, open bracket, X, greater than or equal to 40%.
40 degrees.
Sorry, 40 degrees.
Okay.
Close bracket. Hold me,
Yes, you.
Oh, Z 40 degrees Fahrenheit is equals to 40 degrees Fahrenheit minus 1 degree Fahrenheit.
What is the expected value?
Oh,
They
38
expect
degrees.
how
Sorry.
much?
How much degrees?
38
38?
degrees.
Oh, I said I don't want the one. Sorry, 38 degrees Fahrenheit over 1 degrees Fahrenheit.
So it's Z.
You got 2. Is that right?
40 minus 38 is 2 divided
Divided
by
by
1.
1, yeah, 2 degrees Fahrenheit, sorry.
This is not degrees Fahrenheit, this is what? This 2.
Oh, okay, 2,
It's
sorry.
Fahrenheit.
I'm thinking you're still using
This is
Fahrenheit.
Z-score.
Right. Next.
2.
Do I go to the table?
Come on, Shakira. Procedure. What do we do next?
This is F is greater than.
Well, I see at the table, this next. I don't know. Sorry.
So we find it on the chart.
Draw it
Sorry,
on-
draw the distribution thing and then do mu. And then there's a 2 to the right.
2 is
We
on the
plot
positive side?
Yeah, we plot where 2 is.
Mhm.
And then we want to find 2 behind the blue. Shade.
Everything that
Yeah,
way.
to the right. So you shade that back.
Uh-huh.
And then we go to the table.
Mhm.
And then we find
2.0.
2 okay, sorry, I gotta subtract from 5. 0.5793 minus 0.5. 0.0793. I'm sorry, 0.8 because we using just 1, right?
What?
Oh, I get confused. Sorry, 0.0793.
That can be.
No?
Right.
Do we say take away the 2? I mean,
Go
the
2 by
0.5,
0,
so
right? Take
instead
away the
of
5, right? 0.5793 minus 0.5. 0.0793.
But 2 decimal places.
She used
Yeah,
the wrong
I'm
number.
confused.
When you go in the Z and you use the 2,
Go to
you
Z
say
and
point
use-
seven seven
you're
two,
looking here,
subtract
sorry.
150, that'll be 0.4772.
0.4772.
Yeah, 0.9.
The Z-score is 2.
Oh, 2, 2.
0.9772.
Oh, 2.
Take away
Okay.
0.5.
And then you go
I see what I do.
So you get 0.4772.
0.4772.
772.
Okay. I see what you're saying.
Remember, when we started using tables, I told you to be very careful with the
Yeah,
table.
because I went straight up to 2.
You were saying
And I-
at point 2.
Point 2, not
Right.
2 itself.
And then I took away the 0.5 and I went to 1.5.
So, come. This has to be mechanical.
The Z
Yeah,
has
sorry.
to be 2.
So minus 50 then.
Okay, so what do we do from here?
0.5
0.5
minus
minus
0.4772.
4772.
Uh-huh.
You get 0.0228.
0.0228. Okay.
I get it.
Okay. Crystal, you next?
That's a freshman.
You're going. You're Crystal?
I'm Christina.
Christina.
No.
Desiree.
Oh, Desiree, sorry. I was looking at you before you Crystal. Desiree, you next.
Okay.
Okay, so part B.
So Mr. Will, for all of this, we have to draw this and
Do
graph.
this more often, Mr. Road.
What is the What is the probability that the interior temperature is at least 35 degrees?
P open bracket X greater than, equal to or greater than or equal to 38 degrees, 38.
35. What is the probability it's at least 35 degrees?
So it's greater than equal to 35.
Equal, yeah, 35. Then Z 35 equals 35 minus 38. over 1. So 35 minus 3. So you draw the diagram. Let the mu go over to negative 3. And I missed the whole part with the chart when I was downstairs, so let me try and figure it out anyway. You say never use the negatives on this side. So go to 3.
What
0.998.
green is shade first. What are we looking for? What is the probability
Oh,
that we're looking for?
At least 35, so it's everything
So
Everything this way from where?
from
the
3,
three.
negative 3.
From
from
here
negative
all the
3
way
all
right?
the way over, yeah.
Okay.
So you have, well, I go into positive 3, so 9986, but minus the 0.5. 0.5 minus 0.9 equals negative 0.4986.
Can I get a negative?
Okay, good.
Cannot.
0.4986. 4986.
Now what is this side?
50.
Yeah, 50.5000.
So what do we do?
Well, that's 99,
Point 4986 minus, plus 0.5000, which gives you 99.86. 0.9986, sorry.
Krista, now you.
I'm for a question.
What is the probability that the refrigerator, the temperature, interior temperature will range between 36 and 41 degrees Fahrenheit?
36 and 49?
Jesus, I
36 and 35.
can't hear me, hey. 36 and 41, eh?
41.
41 or 35?
So we go into the P. P is 36 less than or equal to X. And then 41 less than or equal to. Alright?
So when we have 41 and 36 and we only work out 35 and 40.
Listen, let's move on here. Let's go. See?
Okay, I gotta take that. Okay, so the next step would be to say Z is what? 36 degrees Fahrenheit. And then that would be 36 subtract the 38, which would be 2 over 1.
So what's the score?
2. And then we do Z equals 41, which would be 41 subtract 38 equal to 3 over 1, which is 3. And then we're going to go ahead and do the chart. But then we're going to plot the 3 and the 2.
Negative.
They're both positive.
They're not both. You told me this was positive and you said that was negative. Are they both negative?
Well,
You just said 3.
The 36.
The
They're both
36
negative?
subtract 38
No,
is negative.
they're positive.
It's negative 2 positive. It's negative 2 to
And
positive 3.
Negative.
The 36 subtract
Positive
38.
3. Alright.
So we plot the negative 2 and then the positive 3, and then we try to find the difference in between there.
What am I shading?
You're shading the difference, you're shading straight across to the 2 blue lines. And then, so when we go on the chart, we're still going to use the positive, so positive 1, 5, 2, 2.
we have a 2 already.
That would be, oh, we already have 2.
We have a 3. Yeah.
Okay,
Okay,
so we're going to
so
use that 2
second.
and that 3, so we're going to use, for 2 it's what? 4772, and for 3, right now, you didn't rub that in. For 3 it's on the bottom, that is 0.9986.
498.
0.9986. That one right there?
This is what you want. This is 3.
496.
4986.
0.4986. And then the difference between the two is.
You don't want the difference
You
between
wanna
the
add
two?
up.
They are,
Add
yeah.
up. Let's add up. 0.978.
That's what, 4.984. Look at it.
498.
0.9758.
Right.
9758. Any more? One for you. Same question. What is the probability that the interior temperature is between 34 and 36 degrees?
So, x is 34 minus or equal to x. 36. Is that right?
Next.
34. Is that right?
He said next. He wrote it. Yeah, he wrote next.
So we're gonna find the C-score of 34. That would be 38 minus 34 divided by what? 34 minus 38. Oh, 34 minus 38. Minus 4. And now to find that on the table, I'll have.
What's the next side of this?
36.
Oh, we had that. C36.
To the top.
36
We
over
had that.
-2.
We had
It's
that. So
-2.
we two. Negative 2.
Uh-huh.
Draw the table.
They're gonna go to diagram.
We're gonna plot -4,
Negative
-2
4.
to the left.
Negative 2.
Okay, so
Go
negative
to the
two,
left.
Let's see, it's gonna be like right
We are finding between negative 4 and negative 2.
So that's -2.
So negative 2 is, what did you say? 0.4772.
-2 is 0.4772. Okay, and the next one is what? 4? The next z-score is -4?
Yes.
It is.
Okay.
Table it's.
So this z-score of -4, because it's so large,
Right.
when we put this on the table, we do this thing, we do this bounding like that, because it's not on the chart, right? So it's -4. So the highest value for the z-score in your textbook
Is
is
3.
what?
3.
3.
No, it's not 3, it's 3.09,
3.0.
Right.
right?
Oh,
Which gives you an area of what?
9990.
Which is
Minus
what?
point.
Sorry.
And I added 0.01, right?
4.4990.
0.4990, right?
Yeah.
So that means that the largest value in your table is 0.4990, which is at 3.09. Now, by the time you get to 4, that's really going to be very, very close to 5, by 0.5. But you could use the 0.499, okay?
Okay.
So that means from here to there, there's 0.4990. And what we've got to shade, what should we be shading?
Maybe between 4 and 2.
Yes, between 4 and 2. Okay. So what's this equal?
You take away 4990 minus the 4772. .218.
0.0218?
Yes.
Okay. So that's it for that question. So next, let's do this new question.
That's what I thought.
This question is a little bit more difficult. So, okay. The Metropolitan Airport Commission is considering. The Metropolitan Airport Commission is considering establishing limitations on noise pollution. Establishing limitations on noise pollution around a local airport. At the present time, the noise level per jet takeoff in one neighborhood is normally distributed with a mean of 100 decibels and a standard deviation of 6 decibels. Which is really not very loud. Part A. What is the probability that a randomly selected jet will generate noise levels greater than 108 decibels?
P is X greater than 108, greater than or equal to 108.
Okay, so probability X greater than equal to 108.
Okay, so then Z 108 equals 108. That's 100 divided by 6. $1.33.
Okay.
Okay, and there we draw it. And we do mu, and then 1.33. Everything to the right of 1.33.
Okay.
And that's the 1. 1.3. 9082 minus 25. 24082.
Okay.
Then from 0.5. 0.5 minus 0.402.
Uh-huh.
That is 0.0918.
0.09. Perfect. Excellent. Okay. Good. Okay. What's her name again? Joya. Okay. Joya, okay, this one's for you then. What is the probability?
That's another question.
Part B.
Okay.
What is the probability that a randomly selected jet will produce noise levels of exactly 100 decibels?
Reproduce.
Exactly.
Oh, that's where it's tricky.
Exactly.
Produce noise levels of 100 decibels. Yeah.
Of exactly 100 decibels.
So it's
But that's tricky.
Okay, probability that X is equal to 100 decibels. And then 100 minus 100. So you have 100 minus 6. 100 minus 100 divided by 6 equals 0.
It's not equal to 0.
I mean, it equals 6.
It's not equal to 6.
Negative 6.
It's not equal.
It means 0.
Where you get negative 6? 100 minus 100 divided by 6 is negative 6.
It's 0.
It's not equal to 0.
Neg.
100 minus 100.
88.333. 83.33.
100 minus
100
100
is
divided by 6.
0 divided by 6.
Is 0.
83.333.
Yeah,
That's
I
what
get
comes up.
83.3332.
It's really undefined.
Yeah, how is that possible?
So,
Yeah, it's
okay.
not about
It's really undefined. And then we do.
Okay, and then you draw it on a chart.
What is undefined?
And then
Hey.
0.
You.
And
So,
the
So where do I write
Is it
that?
stay?
yeah, but
I'm you.
Right by
I
you.
I see right, what you mean tricky.
And then
Then you
that's
find it right
like
now.
0.
That's a 0.
Yeah,
That's all you have to say in the first
Five,
instance.
6.5.
Wow.
We already went through this.
So
The
9.5 is still
probability
0.
of anything falling on the mean.
Or
it's
the
not a
0
possibility.
on the line. I mean mu.
Or you just
So
write
it's
0. You
undefined.
don't do any of that.
That would have screwed me if you
So
just
we
given that to
put
me.
impossible.
Just putting it up.
Don't put it's impossible. Just put probability is 0.
P is 0.
No.
Okay, so back to you then, Shakira. Back to you already.
Already? That's so quick. Where the rest of the people? There's They must know.
Elgin and Greg and homegirl.
Okay. Well, Greg's getting married today, right?
Again.
Again.
To the same woman.
10
you
years.
was
10
the
years.
boss.
10 years.
10
They
years.
did
They're
it.
renewing
They're
their
renewing
vows.
I thought it was like a wedding.
That's what I said.
I was like,
People really now.
I think I saw
I didn't make the first wedding, so I definitely made the second one.
Oh my god.
Okay.
I was proud of
There you go.
myself.
Suppose that a regulation is passed
But she won't come to my sister wedding.
that a randomly selected jet, suppose that a regulation is passed that requires the noise level in this neighborhood to be lower than 105 decibels. .95% of the time.
You below how much?
Lower than 195 decibels.
105?
Lower than 105
Five?
decibels, 95% of the time.
Special.
Yeah, he gives a special one.
5% of the time.
5%.
Assuming that the standard deviation of the distribution remains the same.
Just a part of this question.
Yes. Assuming that the standard deviation of this distribution remains the same.
Mm-hmm.
By how much will the mean noise level have to be reduced
Katerina,
Hey, Daddy, try to help me.
in order to
How much would the
comply
mean
with this
Have to be
regulation?
reduced to comply? That's what you said, sir?
how
By
much
how
will,
much will the mean noise level have to be reduced to comply with this regulation?
So we assuming everything is the same. This is the same standard.
Well, that's how you can go on.
That's what it says. Standard deviation 6.
So y'all help me.
Let's see.
Proposed regulation is passed on the noise level of the neighborhood to be lower than 105 decibels, 95%, assuming standard deviation of the distribution is the same. So X.
So let's find out what is 105.
I have, yeah, that's my
Or
start. I have,
less than 105.
Which one we do?
I have P, open bracket, X, greater than or less than 105, close bracket.
Okay.
No,
Now,
it's
No, sorry, less than, my bad. Less than equal to.
They say make sure it's lower than 105, but it could be
now,
less than or equal to.
this is one of those questions where it starts to make it very clear that when our brains, and see, it's a human thing, when our brains get used to doing something a particular way, we always want to do it like that.
Yeah.
Yeah.
So we have to be careful with these questions. Notice this question didn't ask you a single thing about a probability.
No, that's true.
Nothing. Didn't ask you a thing about a probability.
That's true. Try to get that
It
wrong.
asks you very specifically, if this regulation says that the noise level must be less than
105.
105, 95% of the time, by how much does the mean need to be reduced in order to make that happen?
105 minus 95, that makes sense.
105
Final
times
eight.
95.95. You find the mean, right? So it's
108 minus
expected
105.
amount, right? Mean is expected, so you have to times something by 95%.
Yeah.
108.
This question is saying to you
So 0.95.
that this neighborhood never wants the noise level to be more than
105.
Sorry, not that it never does. It doesn't want the noise level to be greater than 105, 95% of the time.
Right.
So there's only a 5% chance that this thing can ever have noise levels at 95%, at 105 or more. So it's saying if that is the case, that means that what has happened? The city has bounded the noise level to 105 degrees, 105 decibels. When you guys get problems like this, you don't need to. I suggest that you visualize, you draw the diagrams, you can visualize what this problem looks like. You can't just run and start doing this. You need to I would suggest you try to visualize what this means.
Okay.
So what they're saying is this. Right? They're saying that there is some noise level, there is some average noise level. Right? We don't know what that average noise level is anymore because they're saying that we're changing this whole distribution now. Because before they were just saying the average noise level was 100 degrees, 100 decibels.
100.
Standard deviation was 6 decibels. And I want to know the probability of these things happening. Now they're saying we want to make sure the noise level is less than 105 decibels 95% of the time.
Okay.
So that's a very, very different question. So where is 95% of the time on this diagram? And, hold on. Where is 95% on this diagram, and where is 105 decibels?
105 wouldn't exist, right?
I made a paper chart.
Where does 105 decibels exist?
To the peak?
It has to exist on the right
To the
hand
right,
side,
yeah.
because we know that the average, you guys have to think about these things. We know that the average, they told us before, the average is 100 decibels. So that means then that at 105 decibels, it's gotta be on the right hand side
Yeah,
somewhere.
automatic.
Has to be. Right? So let's just say 105 decibels is here.
So we wouldn't, because it's not on the chart, we wouldn't, like how we did the previous one, we did the like when it was at 4%, it wasn't on the chart, so then we did the closest thing.
4%.
I mean, 4 point,
Negative
negative 4
We
point.
don't have a z-score.
Oh,
We don't
okay.
know what a z-score is yet.
Okay.
All she's doing, she's telling me 105 decibels. It's right there.
I'll get it right. That's
Okay,
clear.
it's over here.
Alright.
So they're saying to us, listen, I don't want the noise level to go above this more than 95% of the time, which means that only 5% of the time is something above this allowed. So that means that we know what? That this little piece of the tail here has got to be 5%,
That makes sense.
right? Which means that everything on this side of it then has got to be the 95%.
Okay.
So since we know that this piece has got to be 0.5, that means that this has got to be what?
95.
0.45.
That's the same thing.
So now we say, okay, they say this 95%, that 95% of the time, the noise is bounded right here. That's all they said to us. I want to bind that. I want to bind the noise
Okay,
level to
okay.
105, 95% of the
Right
time.
here.
So now they're saying, if I do that, if I impose this regulation that requires that, how is the mean going to change in order to make that happen? What do I have to bring the noise level down to? That doesn't mean that no jet can be louder than 105. It's just saying that the average now has to change in order to make this happen. So how do I now make the average change, or tell me what the average has to change to in order for this boundary to always be in place 95% of the time?
Increase it by
The shift is
0.5?
happening.
The same 0.05? So that when it falls in the probabilities of the possibility, it covers the whole thing? Like everybody will be within the
52.5%.
regulation?
Makes sense.
No,
The
not
point
really.
0.5%.
Not really.
Because what I'm thinking is the mean is in between, so I'm thinking like 105 divided by 2.
If
That
I,
would be my new mean.
No. That's not what we
No,
did
because
the
it's supposed
last
to be symmetrical, so if
Exactly. That's the
you
math.
can increase by 0.5 here when this already covers 0.
Exactly. Precisely. I couldn't say that better myself. Precisely.
So,
I think it can't stop working.
It's supposed to be something obvious.
I don't see it.
It's not necessarily obvious. You
Add
have to
the
think about it.
0.05 to the.
See, this is one of those questions, like when I started earlier, I said, we are going to have to get to the point where we understand the way this distribution works. And that's all this question is trying to see if you do. So, here is what,
mine is this score when it's 0.5.
5.
when it's,
0.5.
yes, that's all. That's it. Exactly, precisely. Since we already know that this is where 105 falls, now we can say, well, if I know 105 falls there, I know there has to be some z-score associated with this, right? Has to be. Because all you would do before, if I had given you a z-score and I said this was 2.04, you would have gone to the table, looked for 2.04 and put it there. Now you have the opposite. Now you know what this is.
Okay.
The question is now, so what's the z-score?
Okay. There.
So now what's the z-score? So this one is a little different. This one now says, I know what the probability is. Now tell me what the z-score is. So go to your table, right? look in the body of your table, because now you're looking in here because you have the probability and you don't know the z. So look in the body of your table and tell me where you see 0.4500.
That's point
Seven,
seven,
three,
zero.
six, minus 0.5.
I get 4.6. 4.5.
It's
0.6,
0.4
7, 3,
and
6,
5.
subtract.
minus 0.5, right?
Sorry, who were you saying?
0.17.
Castile.
Christina?
0.67,
I would say
36.
0.6736, subtract the 0.5 over, and that'll be 0.1736.
I want you to go in the body of your table and find 0.4500.
6.6736.
Can't be 0.6736.
I don't even see, oh, you have to go. Oh.
Zero
You're gonna
point
be on
four.
on the
That's
negative
0.405.
table.
You,
You should be using negative table.
you guys are not listening to me. Don't go to this. This is not a z-score.
No.
This is not a z-score.
No, we have to look
This
at the
is the
body.
probability. Go and look in the body. Look
There's
at
We
it.
don't have it because
Because it's going to be
remember,
less than 0.
Right.
we're
So
using this side,
Yeah.
you
Don't
said don't
t-
use that side.
No, because it's going to be less than 0.
You said we can't use a negative side.
No, I'm saying if you minus to find 0.45, it's 0.5 is at 0. And
right.
you'll have to minus 0.5 from it to get it, but it's not there on the table.
We don't have a Mr.
You do have it.
Where?
I don't see it. Because this is 0.5 and it's
Yes. So
calculated on
subtract
top.
0.5 from everything in your table. Subtract 0.5 from the things in your table and tell me where you see
look for
0.5.
0.95.
Clearly.
Increase it by 0.5 then.
Clearly,
so
that means that you need to be looking
0.95.
for 0.95 in the body of your
Yeah.
table.
That's what it is.
It wasn't clear.
It has to be clear. If you're subtracting 0.5 from everything under here to find z, then don't you have to do exactly the same thing to
So
find
that's
that?
The closer one is
1.65.
Okay.
1.65.
So at 1.65, what's the number?
9.9505.
Which is point what?
Subtracting 5.
We're taking 0.5, but now he's saying we can
0.4505.
0.4505.
Yeah.
So you're saying this is the closest number?
Yes.
That's very sure.
The closest
I
I,
mean-
see,
According to what I see here,
we
yes.
can do the math again.
Why is that the closest number?
9505 minus.
Minus 5 is 9. It's 4, 5.
That is the
5.
closest.
So you're trying to tell me that the number just before it, which is 0.4495, is not just as close?
Well,
What
yeah,
about 0.499?
Yeah,
95.
yeah.
They're equally.
They-
0.4495.
Right. So
Yeah.
right
Sorry.
before it, you have
In the 4,
0.4495.
yeah.
Oh yeah, I would have screwed.
So you're gonna keep both then?
So this is a problem.
Yeah, because it's
Right?
so tight.
So you can't use 1.64, nor can you use 1.65 because you have two numbers that are equidistant from 0.45, right? Because 0.45 falls in the middle. Right? 0.4500 falls right in the middle of those two numbers. And that's the one you're looking for. Right?
Yes.
So what do? If this is 1.6, this one here is 1.64, and this one here is 1.65,
You take the difference between them both.
and this is the one you want, which is 0.45, then you just have to average 1.64 and 1.65, which gives you what?
4.5. I mean, the 0.45. So.
This 0.9 is equal to 1.55.
Average of 1.64,
1.645.
and 1.65 is what?
1.645.
1.645.
That's created from.
And we now created one. Now we put a new one on the table.
Yes, because what we've done now is what we call it math interpolated, right? We've interpolated a value because we know that this number and that number are equidistant from this. So the average of those two gives you that. So the average of those two has got to give you the z-score you're looking for, right? Now, that we only did that because they were equidistant. Now, if this were the closest number, we would use 1.65. if this were the closest number, we would use 1.64. But they're both equidistant, like you said, so we have to use the average of the two. All right, so Joya, you were saying once we find the z-score, then do what? So this z-score is 1.645. So now what?
Do we now put it in the formula?
Because now what are we looking for?
Because now we can find the actual z-score.
We have the actual z-score.
I mean, find it for that part though. No. Who's the question asking? You find out how much it can be reduced by?
Well, now we can easily now, we have enough knowns that we can plug that in the formula to do what? To find the new mean. Because they said by how much is the
They did
mean
say
have
that.
to be reduced,
Yeah.
right? So we say, okay, well, we know that. So z is equal to x minus x bar over s. We know what z is. It's on the positive side, so it's 1. And please, when you do these things, if it's on the positive side, make sure it's positive. If it's on the negative side, make sure it's negative. So 1.645 is equal to, what is x here? We do know.
X is now 105.
Yes, x is 105. That's what our value is. Actually, this should just be to be perfectly correct. This should be mu and sigma.
Okay.
So we don't
So
know.
minus some mean that we're trying to find, which is the new mean. I'm just going to call it to distinguish it
Okay.
Divided
over
by
the standard
6.
deviation, which is 6.
So,
1.65, so just now put
So
it in.
yeah, so just isolate, right? So 1.645 times 6 is what?
9.87.
9.87 is equal to 105 minus the mu. So clearly, we want to get rid of this negative mu, right?
Right.
So take that over then as mu, and it's equal to 105 minus 9.87 is equal to what?
Oh, why is it the opposite?
That's 95.13.
95.13 decibels. So that's the new mean. That's the new mean. They said in order, now so they're saying in order for this to be the case, 95% of the time, the new mean has got to be 95.13. So we haven't quite answered that question yet. Go ahead.
How you had the formula, you say 9.87 equals 105 minus the mean. You can, you swap the two. But you have a negative mu now.
I had
And
it
then
right
The
here.
mu is now
But it doesn't matter if it's a negative or a positive in this case.
All I did was algebra. That's all I did was algebra.
She just needs to put it back
I just
over.
took it over there because I don't
To make
want
it
to do
positive.
to make it positive, so I have to
And
take
that's
that
negative.
over there.
Yeah,
So
sorry.
I take it over there and make that negative.
Got it.
I just swap the sides.
Yeah.
Okay, so now we found the new mean and that's it?
We found the new mean, but we haven't answered the question. The question they asked is by how much does the mean have to be reduced to
So
make this happen?
5.13%, so it's 95.13 minus the 95%?
By how much does the mean have to be reduced to make this happen?
So there's a z-score now, what we have, the
The
mean has to be a
9.
5.
The 95.13.
Go ahead. Yes, the original mean was, so mu original was 100, right?
Oh, yeah, that's right.
Minus
Okay, yeah,
mu,
sorry. If you get
mu
the question wrong,
equals
yeah.
95.13. This is exactly how you guys lose little points.
Yeah, so I would
Right?
screw myself.
I would
right
probably
Because
stop right
you,
there.
you did this, which is fine, but you didn't answer the question. So that is equal to what? 4.87 decibels. It has to be reduced by 4.87 decibels in order for this to happen.
My goodness.
Mr.
But you could round that to 5, and you
No.
couldn't just deduct that from that 0.5 right there?
No, because we need to find a new one.
I'm still a little lost.
The old
How
one
we
is still
got-
0.5.
Right on the chart, how we
Yeah,
got the
yeah.
difference between, okay, I know that's 0.5, right?
Mhm.
So how did that right there equal to the 1.645.
Because this was 1.64,
Mhm.
Right.
and this is 1.65. What is the average of 1.64 and
Then we'll
1.65?
divide it by two.
Okay, thank you.
Because that's what you did here, right? You found the average of that and that to find 4,500.
This really sucks. I can't
And
even
then initially you
consolidate.
didn't know if they equally, there's distance unless you subtract both by what we're trying to find out. So you can just do
Okay, this is not-
class is only going to come out.
1.64 plus 1.65.
by 2.
Let's go celebrate.
Mr. Rose?
Mr. Rowe, you want to get some?
I'm not
water?
gonna let this discourage me. I'm gonna pass your class.
We have to do one more question
Let's do it.
before we go.
I'm ready.
So these questions are taking an exorbitantly long time.
If we're going to do this after like 20 to 30 years, I'm almost not doing this. Ever. This is my first time.
I've been at high school longer than you all.
Been learning.
This is your job.
I've been at high school longer than you all.
We're
I
on
remember
this.
this math.
Maybe you are born now.
Actually, I didn't have to do this.
science.
You
The
all,
thing is, I didn't have to do this. I
you
did
all,
chemistry
you all did algebra.
and
Wait,
physics.
it's even worse. You mean
No,
you did more math
I know
than the
about
average
decimals and
person.
stuff, but this is not the same thing.
That means all this is algebra.
Yeah,
So
but
that means you
algebra
did-
part is easy.
You did more math than the average person.
Yeah, but the thing is, it wasn't so much problem solving. It was just more or less
In
like
physics and
this.
chemistry,
And I got A's.
and you don't.
Statistics is
Very different. They
No,
formula
that-
driven, yeah.
decimals. I mean,
Yeah.
I remember
this
the
is the same
formulas.
thing. You have a formula, you throw in some numbers in it. It's different.
Yeah, but no,
that's-
it's not interpretation of
You
the
say
formula.
that, right?
is
But my
used.
teachers were kind of
X minus
straightforward.
mu, that's mu.
Yeah.
C
Yes.
square X minus mu.
Okay, let's look at this problem.
It's not the same.
And chemistry, you have a table all the time.
And I had
so
an
it's
A.
basically.
But the math for chemistry is a
Not
lot
math
more
remain the
complicated for
same.
this.
It's
Only
not
a
a
little
math
bit.
problem here. I bet you, like you could give us a math question for bonus, we'll get it right, but this is the
Don't forget, I did chemistry in grad school and physics in grad school too. It's
You
math
need a
is-
Why do you
Math
become a
is
doctor?
there. Okay, this is just math really.
It is just math,
Okay.
but how to apply it is another situation.
The National Consumer Debt Association.
Oh man.
The National Consumer Debt.
The National Consumer Debt Association
Debt.
Debt.
has asked you to help analyze characteristics of consumer debt.
Analyze what?
Characteristics of consumer debt.
They have sent you the data. But unfortunately, some of it got corrupted in the transfer. You have, however, been able to determine that 32.38%, that 32.38%
2.38%.
of debt holders represent a certain group of consumers represent a certain group of consumers. who hold less than average debt, but not less than $500 in debt. You have also been able to determine that 48.42% of debt holders hold more than average debt, but not more than $20,000. This question is just for consumer debt, so there's things like credit cards, not mortgages and stuff like that. Okay? The association needs you to determine the mean level of debt held and the standard deviation of that debt. Okay.
Here's my thing. What is it asking before after reading all of this?
That's what it's asking.
Yeah, well, you saw it.
So, where do we
I
start?
was just reading.
It's quite a simple problem actually. It's just very
This. What would access?
It doesn't ask anything about probability.
clear,
It's
right?
short.
So therefore, you know, you're right. You're not looking for any probabilities.
Visualize this.
Means we need to add.
So
Okay.
So draw.
start visualizing, right? Start looking at what they're telling you.
Let's try it.
So let's draw the distribution. Okay. So what did they say?
They say 30 to 138 is 500.
32.28% of the debt holders.
32.38% of the debt holders. Why can't I draw this to my screen?
Percent of certain group
That's
who has less than average debt, but no less than 500.
Okay. Don't less than $500 in debt. So okay. So how are we going to represent that here?
We gotta plot the 500 first, and then that would represent
Okay. We know that $500 is going to be where?
to the right.
Where's that $500 going to be?
On the positive side.
Why on the positive side?
money.
Not because it's money.
I mean, they did say debt though.
There's nothing
Yeah,
debt.
you have to look for keywords.
Read the question. 32.38% of the people
Are in debt.
hold less than average debt,
Oh, okay.
but no less than $500. Read the question. There's the average debt.
And then there's
These people, 32.38% of those people hold less than the average debt, but no less than $500. So where does that have to be? It has to be on the left hand. The question is telling you
Where it is.
where it is. Average debt is here, and this 32.38% of the people hold less than the average debt, but no less than $500. So they're saying that $500. We don't know exactly where it is, but we know it's on the left, right? But what we do know is what? That from here
Mhm.
to here represents
32.38% of the people.
38% of the people.
Okay.
It's represented from here to here.
Mhm.
Question told you that. You didn't have to guess that, you don't have to figure that out, and then you really, question said it to you. Just read what the question says. And then it says, what about the other people?
You also have been able to determine that 48.2% of the deaf.
48
more than them.
That's the question said, right? 48.2.
Yeah, they owe more than average.
You have
than
to-
I got.
More
They
than
have-
average deaf, but not more than 20,000.
It's not 48.2%.
48.4 to
48.42.
Okay.
So 48.42% of the people hold more than average debt, but no more than how much?
20,000.
But no more than 20,000. Again, we don't know what it is, but we'll just say it's right here. And this represents
48.42.
48.42.
So the association makes you to determine the mean level.
So now that we know these, what can we know that this number and that number have got to be associated with what?
0.5
This number
respectively.
and that number has to be associated with
Total debt.
what?
The total debt.
Yes, but they also have a sign to them what? They have z-scores. They have z-scores assigned to them, right? Because you know what the areas are, you know what the probabilities are on these in this portion of the table. Therefore, we know that these numbers have z-scores. Go to your table and find the z-score associated with 0.3238.
Um, 9.03. 9.03.
Point.
9.03 gives you 8238. Because you have to add 5, right? 0.5, so you get the number.
So what is the z-score?
0.500.
9.03.
That was 0.9, right?
0.9.
Because it's dot 9.
Oh, okay.
0.93?
3.
My bad, sorry.
Okay, so 0.93 is going to give you 0.38, so 0.22, yeah, 0.3238,
Yes.
is that right?
Uh-huh.
Okay, so
That's the
means,
exact number.
okay, so that means the z-score is 0.93, is that?
Yes.
Okay. And then what's happening on this side?
Yeah.
8. That's 2.15.
So 2.15, so 2.1, so 2.15 is 0.4842? Okay.
Yes.
So this is 2.15. Okay.
And the second one is average, right?
It's 42 plus 0.5, so that gives you 98.
Oh.
98. 42.
Okay.
Okay.
I'm listening.
Oh no, I found it's between 98.46 and 98.50. They both in the middle of 98.48, right?
No, 9848 should be right on your table. 9842 should be right on your table.
Yeah, that's right
You don't
there.
have to
That
find
is-
two.
Oh, I
Two
have
point
48.
2.1
My bad.
to 0.5.
Oh, you have 9, but you have 9848.
Yeah.
Oh,
2.1, yeah.
okay,
Sorry.
you guys don't write.
Oh, sorry.
Let's stop this writing.
Yeah.
Because now, we've gotten a lot, we've gotten far, right? But we have a problem. I gotta tell you again, when you guys are doing this, you have to be extraordinarily careful. This 0.93 is negative. That is a negative z-score. That will cause you so much pain later on today if you don't make sure you assign a negative to that.
Puts it on the negative side.
Okay? Alright, so means I can get rid of this now.
Need more space to this one. No.
So-
Gave us 4, 2, but this number's on that, this number.
Alright. So here we know, right? We know that this $500 is assigned
Go up and go down.
to this negative 0.93 z-score.
Yes.
We know that this $20,000 is assigned to this positive 2.15 z-score, right? So once we know that, we can say, all right, well, how do we find mu and sigma then? Well, we know that z is equal to x minus mu over sigma. And we know clearly that z is equal to x minus mu over sigma. So we know the z-score over here is negative 0.93 is equal to x is $500 minus mu over sigma. And we know over here this positive 2.15 is equal to 20,000
I mean 20,000.
minus mu over sigma. And we say, all right, well, clearly, and I say clearly again, they asked us to find these because we had incomplete information. We don't have them, but we have enough information to find them, right?
What do we have to do?
So I would just label both of these 1 and 2, and then solve for it. Just solve for
Oh, is it
for
simultaneous version?
Yeah, just solve for it. Solve for mu and sigma simultaneously.
Do I have to variable?
I was just thinking about that, even going back to simultaneous.
So, yeah. So what I would do first, right,
Wait a minute.
is because I know that these two quotients are going to give us problems. Quotients get very messy in simultaneous equations, and as you continue to write, don't ask me for anything after this because I'm telling you what we're doing.
I'm looking.
Okay? Because I know personally, you might feel differently that quotients are not a problem, but I find quotients to be problems in simultaneous equations. So I always get rid of these first
Yeah.
by multiplying both sides by sigma. So I multiply both sides here by sigma and I end up with negative 0.93 sigma is equal to 500 minus mu. And do the same thing here, multiply both sides of the equation by sigma and I end up with 2.15 sigma is equal to 20,000 minus mu.
Can you say mu?
Then I relabel these 1 and 2 because these are going to be my new functions. And then I say, okay, well, I know that I want to be able to, now you can do this 10 different ways. You can either subtract one equation from the next, or you can use substitution, which may be a little easier, I don't know. Some people find substitution a little easier. So you say, if you're going to substitute, we're going to have to subtract here. If you're going to substitute, you need to express one of these in terms of either mu or sigma, right? It's very easy to express this in terms, either one of these in terms of mu.
Because mu and now.
Right, mu is very isolated. I would use this one because this negative is in my, give me a little bit of problem. So I would use this one, I would say, so take 2 then and work with 2. So I take 2 and I say, okay, 2 is equal to 2.15 sigma is equal to 20,000 minus mu. And I want this to be, I want mu to be isolated, and I don't want it to be negative, so I take it over as mu is equal to 20,000 minus, right? 2.15 sigma. Okay. So I have mu expressed. I have an expression for mu.
Okay.
Yeah, so it doesn't really matter which one you use. And then I say, okay, well since I worked with 2, then I say substitute in 1. Or any direction you want to, doesn't matter. You could have worked with 1 here and substitute in 2. Great difference. So I'm going to substitute in 1, which is negative 0.93 sigma is equal to 500 minus mu. So now wherever mu is, I want to substitute that in.
So that sentence right there, that
That-
20,000
Right, I want
minus
to substitute this expression wherever mu is. So negative 0.93 sigma is equal to 500 minus, and because I'm slow, I always like to make sure I write the whole thing in. Minus 20,000 minus 2.15 sigma. And then I say, okay, well, negative 0.93 sigma is equal to 500 minus 20,000 plus 2.15 sigma.
Yeah.
And
For the sigma
so negative, so now,
Trying to bring it here and there.
now I just need to collect my terms, right? So I'll just bring the 2.15 over here, so negative 0.93 sigma minus 2.15 sigma is equal to 500 minus 20,000.
Then you work out
So
each side.
1.22.
this is 4 point,
Oh, 1.22.
negative 0.93 minus 2.15,
Negative 3.08.
negative 3.08 is equal to 500 minus 20,000,
Negative 19,500.
negative 19,500.
So you drop sigma.
Sigma,
put
sorry.
back.
Sigma. So,
Not substitute.
so now what I want to do?
So we divide.
Substitute
Just divide, eh?
Divided by 3.
Divide the negative 19,500
By
by the
308.
negative 308.
Right, so divide both sides by negative 308, give me sigma is equal to
19,500. I get 5131.
5131. No,
It's 60.
Negative 19,500.
I got 633.17.
633.1.17. Give me four
If you
decimals.
round it, well,
1688.
1688.
1688. Okay, so that's sigma.
So you already find sigma, now we're gonna find.
Yeah. So now
We owe you business to do now.
we have mu already expressed.
Substitute in there.
So we should just go back and substitute in 2. Or I usually say return to 2, but as you wish, whichever. Substitute in 2, so mu is 20,000 minus 2.15 sigma. So mu is equal to 20,000 minus 2.15 times 633.1.1688. So it's 20,000 minus what is 2 times that?
12662.3376.
12662.3376?
Yes. It was 633.1.16 times 2, right?
Oh yeah, but what's, oh, you were giving me, oh, sorry, I thought you were giving me the answer. Okay, what does that equal then?
I get 136.
You know, kind of.
My God.
I got 7337.6623.
I didn't get that.
What did you get?
No, I didn't get that one, too.
126, 609.
126
609,
609.
comma 764. I mean, if you put in the thing, that's right. I don't know.
Why those are
I might calculate it wrong, eh?
When I get
Let me-
13612.01. 13612.01.
612.01. Okay, so what is 20,000 minus that?
Oh, I matched it.
6387.
6387.99.
0.99. Okay. Alright, so now we have mu.
So can we right now?
And then, right here, before you, I mean,
Okay.
before you move from here, you better check this, right?
To make sure.
So, right, so we worked with 2, subbed in 1, we subbed in 2, so we should we should really check in one, eh?
So we'll fill them with these figures here, the signs.
Right.
I see how you put return, yeah, put return.
See, that's why I keep on return. It makes more sense to say return. Return to 2. So now check in 1, and 1 was expressed as, where's 1? Oh, 1 is negative 0.93 sigma is equal to 500 minus mu. So negative 0.93 times sigma
It was
is
6,331.688.
minus 500 minus mu is 6,387.99. So what is
5887.
Negative
5887.
negative 5,887.99?
0.99.
What is
How
5
could it be an equal
minus
sign?
that?
And Mr. Rowe, before the 500 is supposed to have an equal sign?
Yes.
The same thing?
Yes.
Came out?
Yeah, so you should balance.
899. 5.
5,887.99. So then you know you're right if you balance.
5,887.
Yeah, the practice 100 times.
Yeah. So you say, okay, didn't make any errors, because that's the only way you're going to know that they balance.
Okay, so it's a bonus.
How much does something like
So
this
not be a
work?
bonus.
How much something like this work, Mr. Rowe?
On this exam, this was worth,
Like 30 points?
It can't be 10 points.
was worth 15.
It's still not
Take it right now?
So right now, because I'm done.
Now, Mr. Wood,
You need to
you
be
might
on
be a little
code.
upset with me, but how we get that negative 0.93 and that 2.15?
Y'all can explain that, because we just did that.
They writing,
Okay, what had happened was, because I have a
I'm
special
going to let
too,
them explain it.
the negative 0.93, you have to add the 0.3238, you have to add the 0.5 to it in the book, because remember, we always took away 0.5 and we orders not.
Just so
so
you
we
have
adding it now.
So now you have to add the 0.5 to it, and that's how you get the numbers. And it has to be negative for that one, because
It's
it was
on the
on
negative-
on the negative side.
On the left of the.
Don't worry, it took me about
Expected
20, 30
value.
minutes to figure that one
Y'all
out.
go get the other tables and require y'all to do those subtractions, because
This could be.
y'all, I mean, because every single thing, additional thing you have to do takes time, and you don't need to have forgotten to subtract 0.9 or add subtract 0.5 or add 0.5 to get a round number.
I get tried.
So just take it out, just try to get the formula without, that already has the 0.5 subtracted, only using the half. I mean, you just download it offline, I think that's what they did last semester. Alright.
And you don't have it where we could get it from the copy from it.
No, so get it offline, I
The
don't use
principal of the
tables.
book, what she said she was giving me.
Yeah, Therese. I could call him. I told him not to fax it to me, because like back in the office now. No, she could just fax it to me then.
Yeah, I think it's from the 8th edition, from the 9th edition down, as the.
She showed it to me, but I
Yeah.
didn't take it from her right then and there, because it wasn't as far yet.
But when you get the can you bring copy for the whole class?
Everything else, like the God said, it's like nothing.
It's like nothing.
Mom, listen, no.
That was fun, eh?
So much fun.
Yes, remind me next week, because we still have a lot to do with this chapter. But we're gonna have to finish chapter 6 and chapter 7 next week. But you are gonna have a quiz next week as well on everything we've covered up to this. I will tell you right now what will be on your quiz is one of these and one of the other questions. And you have 30 minutes, so this can't.
Oh, so we just
quick.
wait for what we did today till now.
Right.
Okay.
So it'll be 30 minutes, then we'll finish chapter 6, which includes binomial approximation, do chapter 7, which will take us a couple hours. Then we'll be ready for chapter 8 the next week, and we'll have another exam, and that's it. Then we have the final.
Oh my God.
The final is the week after.
Oh my God, how much is this final worth?
Yeah.
The first test that sucked. It's on a Saturday or?
Usually. Usually it's on Saturday.
I don't mind
Mr.
the
Rowe,
Saturday.
whatever it is you want us to do, we can do.
So, we do, but we are running a little behind. So, if you want to have an extra class, if you guys ask,
Yeah.
you could do that on Fridays. I have no problem with that.
I don't mind.
I couldn't come last Friday. I had some people in town and I forgot that they were coming. That's why I had to cancel last week's.
Oh, I was blaming the
Right.
institute, not giving you a classroom.
No.
I'll say.
I never voice
I was
missed.
cursing because I was absolutely,
I need
So,
it.
if you guys want to have the class on Friday at 6,
yes.
okay, I'll arrange
You
that.
want this Friday?
We'll just do it every Friday from now on.
Yeah, I don't
How much
mind.
time?
It's not
I don't
really,
mind.
you know.
I just catch myself.
Snap a photo like this, so I could just do this like this.
So what about
We
those
signed
things
it
on
on the register.
Those things on my paper you corrected.
Oh, come.
Oh, shoot.
Erase it off the box, I think that was.
Anybody on the hill?
Anybody what?
Anybody on the hill?
Me.
Okay, I guess we do this to
Okay,
the
so I am wrong. I have phenologists.
Funeral on Tuesday. Family, family.
Yeah, my cousin died yesterday.
Oh,
Yeah.
Oh, they were sick.
She had cancer.
She's young or old?
That was this one.
So
You can find me on the
condolences.
email from Mr. Garfield and I can tell you what he did in the cloud.
Yeah, because most likely he's just going to highlight the notes that he did.
Yeah.
That's not okay.
No, I can tell you, I can remember to find your email.
And the other one, we're not
You know, my
negotiating.
co-worker.
Whichever one. That's the initial that I'm on.
Go on like the 58%.
You saw your register.
Yeah.
58.
No, we didn't.
58% for representative.
We signed a register when we did the exam.
Yeah, but
What I'm trying to say.
yeah, but what is this? You didn't tell me this was part A. You didn't tell me what that was. You said about this thing. Yeah, I mean, it's one second.
Says.
What do you get now?
Higher up. 43.
Yes.
I was pretty happy
I
with
do
that.
it.
She gone up.
This and then this one. Hey.
Not by much, much.
Better than I thought it was supposed to be.
You were saying for this,
Hey, because you remember that.
I think it was in this page.
Yeah,
So it'll be 9842. We adding point 5 to the 4842.
Excuse me.
Probably gotta go, my niece is sending my daughter already.
They ready?
Oh, yes, question 50.
They done called me about 50 cents.
When Asa was here.
Kira, what are we doing?
Hey, I know what practice to stay. I wanted some comfort to stay.
That's what it comes out of the practice.
That sounds even better than usual.
I finished right just when I go home.
Take a picture on your cell phone.
I already done.
Yeah.
That's a good way so when you write it back in the event, you can study it there. Anyway, I will WhatsApp you.
Oh,
I will WhatsApp you.
you WhatsApp me something?
WhatsApp
Yes.
us.
Okay.
WhatsApp us.
You get my number, but John, that's me. I can't send you anybody else.
Don't worry.
Yeah, that girl.
I think we actually get this part, it's just long. Long and long.
need to go for a sweater, but like,
Cool.
I don't
You have
need-
like some, you have like some?
I don't usually be cold, this is the first time I cold with this.
That's a weather.
Like,
weather.
I don't know.
I don't, yeah.
Let me just use the trumpet.
There's three. They're calling me Desmond.
Okay, D.
No, she's calling me you.
D. Alrighty.
Alright. Let me show you this.
Gotta get it right.
You see how it says 0.2238, right? You add 5 to that, so that gives you 0.8238.
0.8238.
Okay, so
So,
that's right.
see, you look here up to 0.8238,
Where it is
which is 0.93.
Yeah. It took me about 20 to 30 minutes to figure out what the hell did
Because
you
no, when you
get that.
explained I was getting 0.8, I said, I must be a dunce. Because I
Oh.
was getting 0.8. Something.
Anyway, Mr. Road, I apologize for keep moving, but I wasn't feeling too good, so that's why I had to keep going to the restroom.
Oh,
No, I mean, I see how you tell Elkin, you need
like
to,
it was up and down the place. Man. Just,
yeah, but that was
and now he can never do anything quietly. He have to move, and you gotta hear him. And
So that was my issue. My sugar freaking out.
oh, well, that's not
So I had to,
good.
I kept feeling like I wanted to throw up.
And you want to take your shirt out?
I go in the
You
house
want to
too
start a
late.
vegan diet with me?
Nope, I can't.
Aw,
I have to have certain things in my diet.
you could have all kind of sugar. My goes.
Why would I want sugar if I'm a diabetic? Let's go.
Sugars.
See you right over there.
Okay, Lord. Let me figure this one out. We got a house that's freaking for us. I'm staying in there. Yeah. Tell me right now. Make sure my brain power on me. Well, I just carry your ass straight home. No bank card.
Because I write down the 5 months today.